we can make a difference and transform this grim picture into one of hope and sustainability.
ओके अभी वो अरेंज
Let's
करते हैं वो
embark
आ
on
रहा है
this
बंदा वो
journey
खाना खाने के
together,
लिए गया वो भी
driven by
आएगा
a
सर अभी
shared purpose and a determination
ओके
to create a positive change. Thank you for being here, and let's make this grand finale a remarkable step towards a plastic-free and sustainable future.
मेन इम्पोर्टेंट है प्रोग्राम से उसका क्लास रिसीव करना आज भी वही हुआ है आज भी सॉन्ग में दिया कोई नहीं हो गया पर वो डांसर रेडी है बिल्कुल ना वो खत्म हो गया रेवा
To professional services and of new age capabilities and industry solutions that can be deployed at scale. Mr. Naveen is an alumni of Bangalore University and IIM Bangalore. He will be sharing his invaluable insights. Today with us, please join me in welcoming Mr. Naveen Kamat with a warm round of applause. So please.
Hello everyone, good afternoon and a very warm welcome to all present
इधर आओ,
here in the
दीपक
auditorium.
कहाँ जा
Hackathon
रहा
participants,
क्या है उधर
management and faculty
क्या
members,
है उधर क्या
REVA
है
University,
मैच चल रहा
colleagues
है
from
हाँ
Kyndryl,
तू डांस करता
students
तो
and
फिर
also
ये
any of
मैच
you
करो
that may be
चल
joining
करो
online. I know we are on a very tight schedule here, so I'll promise to keep it brief.
हाँ उधर क्या
Firstly,
करना
I think it's very encouraging
क्या करना
to see the
वर्क
excitement
क्या है
and
अपने को उधर
passion
वो बोलो ना
with which the Sustainability Hackathon with the theme of plastic-free rivers using AI.
कौन है
That it will have on
हाँ
business.
कॉल करता हूँ मैं सर
And on the other end of the spectrum, there is
हाँ
skepticism around how these technologies can be harmful for societies and economies. I'm personally convinced that with the right use of technology, there are so many real world problems and ground level issues that we can solve. That we can use technology to uplift the quality of life, provide food security, promote biodiversity, and influence in a positive way the climate change issues that we have. Provide for basic livelihood needs of many, and leave the world a better place to live in for generations to come. AI can accelerate the transition for all of us to be a meaningful contributor to a purpose economy. The response to this hackathon is a huge testimonial to that spirit of innovation for a shared and for a greater purpose.
ये लैपटॉप बोलो उसको हटाएगा
On behalf of Kyndryl,
उधर
I'm very
नीचे रखेगा
glad
बोलो
that we have been able to host this hackathon
हाँ
through the
ठीक
REVA University, provide a forum for collaborative creation around a topic that is close to our hearts and
चलता
minds.
रहेगा कुछ नहीं चाहिए वहाँ नीचे डाल देंगे तो चलेगा ना सर
Our
चलेगा मैं
collective
इधर निकाल देता
commitment towards a sustainable future.
और रखे कब तक बैठेंगे
I also
खड़े
take the
रहेंगे कब तक
opportunity
बैठेंगे
to
आपके लिए
thank
चाहिए ना
everyone
लैपटॉप के लिए
involved
थोड़ी
in
देर चाहिए
designing this
हाँ रख
hackathon
दो
together.
डब्बे को ऊपर रख दीजिए चलता रहेगा ना
And of course, all the participants that have made this hackathon possible in a grand way. We have exciting next few hours ahead of us, and I wish all the finalists the very best as we listen in to their solutions and what they have as part of their submissions. So thank you, and without further ado,
Thank you so much, sir. We appreciate you for sharing your enlightening insights with us. Now, to add a touch of artistic brilliance to our event, let's welcome the talented performers from our performing arts group for an invocation dance.
लाइट बंद करो हाँ लाइट सॉन्ग पोडियम लाइट सॉन्ग प्ले करो या प्ले करना है अगर वहाँ से प्ले कर रहा है तो 30 किसने है दिख रहा है यहीं से प्ले कर हाँ प्ले कर रहा है लाइट देख लेना और टीवी वाला नहीं टीवी पे नहीं उधर कर रहा हूँ टीवी ये यार स्टेज पे छोड़ गणपति है गणपति है गणपति
बस एलिगेट्स जिसको थोड़ा और ब्राइट करो मार्कर थोड़ा बढ़ा वीडियो वगैरह जो भी है वहां से प्ले करेगा ना अपना तो रजिस्टर होगा
What a mesmerizing performance. We offer our profound gratitude to Miss Neha, Mr. Madhu, and Miss Vandya Mahesh for their spiritually uplifting invocation dance. Your divine artistry has touched our souls and brought us closer to the sacred. Next up, we have on our distinguished guest list Ms. Girija Mukund, Director of Corporate Social Responsibility and ESG at Kyndryl India. Ms. Girija Mukund is also CSR and ESG leader. She is responsible for pioneering and implementing Kyndryl's CSR strategy in India. Before joining Kyndryl, Ma'am was leading the CSR and corporate compliance verticals at Global Foundries. During her tenure at Global Foundries, Ma'am was instrumental in setting up and scaling the CSR, ethics, compliance and corporate secretarial functions responsible for board compliance and policy management. She has pioneered programs in women empowerment, healthcare, skilling, climate action and education. Earlier in her career, Ma'am has worked with major global organizations like AMD, Intel and Motorola in diverse roles. Ma'am holds a post-graduation in social work and business administration and is a certified project management professional from Project Management Institute. I'm delighted to extend a warm invitation to Ms. Girija Mukund to take the stage and offer her significant perspectives on sustainability. Your applause and warm welcome as she joins us will be much appreciated. Thank you.
Free reverse with AI. So when we talk about sustainability is the problem for this century and for our generation as well. And if we really want the next generation to lead a better future, the coming generations to lead a better future, then it's time to act. And they are already there, and we all know that. And when it comes to sustainability, it has some responsibilities.
देखिए गिलास ना चल मार एक रहा तो रहा हाँ चल गिलास मार देख रहा
There is the society or the social factor. There's also the economic factor that we talk about. And sustainability is environmental factors. We all know that it all depends on how sustainable the businesses are, how sustainable is your operation. And when it comes to the society or your social elements, it is your everyone in the value chain,
इसको बोला था
whether
चीनी
it
और
is
इसको मिलाना
stakeholders or whether it is employees or the community, everyone value chain. That is the bottom line of the economy, and that's the element that comes in. And ensuring that we have a sustainable operation,
ये बात है
sustainable development goals,
मेरे पास नहीं है तो बना खाना नहीं खाने का तिनका बर्बाद और खाना खाए तो काम लगा खाने काम कुछ रहा है क्यों इतना परेशान था काम कुछ नहीं रहा तो आप करे अपना काम था ऑडियो बस ऑडियो इतना परेशान क्यों थे तो क्या करे क्यों करे ना करब ना भैया मान दियो पर दो ऐसे झटके होते हैं अरे भैया जल्दी छुट्टी आवे के रेडियो लगावे ना आराम से करो ना बहुत कोई जे देखिए प्रगोन पीछे चले फाइल फोन पे चला जाओ कई बार
I remember when sometime back, this was a great thought and the idea that we wanted to see how do we get solutions into technology and how to implement AI in identifying plastics that are all over the world. And it's a great start and a great thing for us.
अरे सब तोड़ दे पाते तुम
And
पास
this part here is the response that
हम
we
बात
have
करते हैं
from Hackathon. Great response and
अरे का
energy we have seen very nice to see top finalists. So I would like all the very best.
जाते हैं रखो दे
On behalf of everyone present here today, I extend my heartfelt gratitude for sharing your expertise and wisdom with us. Your dedication to corporate social responsibility and sustainability is truly commendable. and your presentation has been a guiding light of inspiration. Now, to shed light on the essence of our event, let's welcome Dr. Shyama Raju, who will provide us with an overview of the hackathon and the evaluation process. Ma'am, please.
Very good afternoon, everyone. How excited are we? No excitement? Yes? No? We are here. I can see a lot of stress that some of you are, which is there on your face. We have reached the grand finale. It has been a tremendous journey of teamwork and great learning for all of us here. So, without further ado, let me just quickly share a few things. But before that, those who have come first time to the campus, they should know about REVA University. We are the most promising private university in South India, but then we have aspirations of global university. We have 15,000 plus students and 2,000 plus staff catering to higher education, and a series of programs which is in various areas. Our chancellor, you will meet them, especially on the grand finale, the later events, that you should see the visionary that he will. And we have our vice chancellor here. We also would want to take a moment to introduce the hosting department. We call ourselves as REVA Academy for Corporate Excellence. We focus on consulting, research, corporate programs in some of these areas like data science, AI, cybersecurity, cloud technologies, techno-functional leadership, etc. And we have a great vibrant ecosystem, the kind of partner support system that we have in catering to our discerning clients is amazing. The whole rationale of starting this hackathon with our esteemed partner is just big shout out from all of us to Kyndryl, because they've been a phenomenal partner with Naveen and Dan and everyone else who has been there throughout the whole thing. Our intent is to encourage, inspire people towards AI solving real life problems. We also would want people to take up, especially students who are attending this program, to look at projects and patents which is more useful to the society. And let us work towards the planet. Because in my generation versus your generation, you will have tough time dealing with plastic and everything else that our generation has achieved. So let's work towards solving some of these problems which are there. And a lot of statistics, I think, we know that plastic we are eating, we are inhaling, and everything around us actually in a micro nano way we are consuming plastic. Now, I think from the events and everyone's perspective, there are a lot of agenda which has been taken up by a lot of us, that let us look for making our planet sustainable for billions of others. This has been a 4 month journey. हम नहीं काम कर सकते हैं pre-launch has problem formulation with the help of multiple iterations. I think we would have had about 50 plus iterations to identify this problem. And then we launched it, and as Naveen mentioned, we got phenomenal response. Almost 30,300 participants. But today we are here. We are at the grand finale, chosen 15 participants. So big shout out to everyone who has reached the countdown is going to start now. Now let's come to the business that we are in. Here for evaluation. Evaluation criteria would remain the same. That we have just towards the technical excellence of the solution, plus everything else. We are looking at 25% of your score would come from technical efficiency and optimization. 25% would come from demonstrability of the prototype. 20% would come from solution architecture and feasibility. Then each for creativity, innovation, social quotient or sustainability quotient, and teamwork and leaders. So there are a lot of scores you have to earn to reach that final five. So this is I know it is a challenge because we have been kind of limited. Now let me take. I know we didn't have an occasion to actually honor all the guests who had come. So I would request Dr. Ashmi to take flowers set of these flowers. So I think we have occasion like online, but can we have? I think we should start with Naveen. Naveen, thank you so much for all the support. Please accept this flowers on our behalf. Big clap to Naveen. Can we have Manoj? Manoj is the Director Data Analytics Kyndryl India. Manoj, this is your turn because you are the jury. So if you have any expectations or 2 lines, if you would want to, can somebody give me mic?
Yeah, so first of all, congratulations to everyone and this the sustainability is something that we are day in and day out in the industry. So specifically, I'd like to call out two instruments that we are currently working on. One is mining company in Canada, mining gold. So we have a lot of focus on sustainability, especially with a lot of water. We go through roads and then get to final byproduct. So some of the investments, which the company is also talking to investors. So a lot of investors focus on sustainability measures that these mining companies take before they kind of invest in the company. So that's something. And recently, in the retail space, there's a lot of focus on sustainability So we are focusing on solutions like how we can use this make retail more sustainable using a number of based on historic data. If the product is always the design is dirty, but always fits on the size that it is. So then gather all the data and then you identify and provide recommendations and then you start putting the product. That's one area. And then secondly, as the product comes back to the warehouse, there are multiple things that first can do. One is they can either restock it based on the value of the product, or they can send it back to the seller, or they can move it to kind of CSR program. So again, a lot of questions that can be taken based on there are multiple industries in fact, so I just want to follow these two. We are going to spaces of thanks.
Thank you, Manoj. I think Manoj is going to be a tough judge or a fair judge or an easy judge. We are interested in that, right? No, yes. Okay, so I do know that Kyndryl has been doing a series of things around sustainability and going carbon zero, carbon neutral by 2030. There are large policies. But that is a lot of interesting stories. More we read and more we read, I think we are harming the environment. We should be careful at every level. I think that's the story that everybody has to know about. And we have to thank she is techno nerd, I would say. She's chief officer, except protocol. She's amazing hackathon person. She's a critical woman Calvin Long Master. Here for Usha. And so usually she is going to be a judge answer. Usha, you want to say anything to the presenters?
Yeah, I'm wishing all the finalists the very best for your presentation. Communication is very important.
Sorry, streaming or issue and it's one.
So how you present it is all the finalists is very, very important. So clear. And I would also like to thank Chief Race and Kyndryl for coming up with this hackathon. So I travel across the country for So there are a couple of cases where they identify me as a judge. You are the judge for the hackathon. So this even has been very deep across India. And hats off to Race and I would one piece of advice to their shares I would put in process. See the thought process of sustainability
माइक में जो ऑडियो आ रहा है आपके पास आ रहा है तो आप मुझे ऑक्स केबल में लैपटॉप में लगा सकते हैं
वो ऑक्स केबल उसका आउट चाहिए आप
हाँ उसका आउट लैपटॉप क्या इन में जाना चाहिए छोटा 3 mm केबल आता है ना
ये तो कैमरा से जा रहा है सर कैमरा
नहीं वो वाला नहीं चाहिए मुझे जो बात कर रहे हैं ना वो चाहिए
वो रिकॉर्ड कैसे
माइक में जो जा रहा है ना वो चाहिए मुझे उसको वीडियो छोड़ दो वीडियो का चिंता ही मत करो जो आ रहा माइक का जो आउट स्पीकर में सुनाई दे रहा है मुझे वो एक आउट इसका चाहिए
Usha has been a
केबल
great
चाहिए
advocate for autism. Please follow her. She has tremendous work in the social causes. With her technology
आपको आउट चाहिए वो मेरे को मालूम है आप बोल रहे हैं इसको बट आपको जो लाइव जो जा रहा है सर कैमरा का ऑडियो से जा रहा है ना
नहीं कैमरा का ऑडियो नहीं जा रहा वाला
हमने वहाँ से स्क्रीन शेयरिंग किया उस लैपटॉप में जो वहाँ पे मैम बात कर रही है ना उसमें स्क्रीन शेयरिंग हमने ऑन किया ठीक है स्क्रीन शेयरिंग से यहाँ पे चल रहा ऑडियो अगर जब माइक नीचे आता तो तब क्या हो रहा है जब पोडियम से बात करो तो चलेगा जब नीचे आ रहा है तो वॉइस एकदम लो हो रहा है तो माइक का आउट जो यहाँ से आएगा तो हम यहाँ से उसको कनेक्ट कर सकते हैं वीडियो से कुछ लेना देना नहीं है
If you participate in it, it's a platform. I want to say people who are here, people who are outside, I want worldwide to hello.
We've hired about 62 students this year. We're also looking at hiring more next year. That's another thing that I want to talk about. Thank you so much to REVA and the administration for that. There are other programs that is coming up as well. I know other still she is working on some, she and her team are working on some of them. So I will let them talk about that. About sustainability, I want to touch upon certain basics. We can't completely get away with plastic. All of our juries, guests spoke about it. But maybe we do small things, basic things. All basic stuff that we can do.
Here,
I also want to thank Dan has been a pillar always with he has been incredible. I've watched him do all this stuff. I try to support, but he can't always does in the back, always does it. I don't see it. Thank you, Dan.
I think one flower bouquet must reach there.
Oh, we have it. Thank you. And congratulations to all of you who made it here. Wanted to participating first.
We have Kumar Saurabh. Thank you so much for mentoring our participants. And some of the team are vying for the slot. So whoever has not seen Kumar Saurabh, who has been your mentor, big shout out to Kumar. Thank you. Thank you. Okay. So I think let's move on because we are we just got a good we have a few things for the audience. Please tweet. We are tweeting. Why we should tweet is that let's create the simple awareness. Can they be plastic free, right? So these are the hashtags. Please note it down. Plastic free with Kyndryl REVA. Kyndryl REVA with SDG 14. SDG 14 is about life underwater. The fishes which is consuming all the plastic that we are every day discarding without a thought. So please tweet and let the momentum continue and let larger audience get to see what we are doing. And let the best team win. I think this is the biggest wish we have to all of you. So with that, we are on. So jury members, I hope you are ready for all the evaluations. We will have a first team. Thank you, Shyama, for an informative view. I think the gratitude to all the judges for your valuable inputs. One announcement we have तीन मिनट गया your mics are turned off. It's creating disturbance. Thank you. As soon as get ready to discuss your feet as we introduce an electric lineup of exceptional teams for our upcoming event.
Each team is trying to deliver a jaw-dropping presentation that will leave you in awe. Without further ado, let's set the stage on fire with our phenomenal team. Kicking off this extravaganza, Syntax Players will set the stage ablaze with their presentation. Brace yourselves for an adrenaline-packed start.
हाँ सर हेलो सर बोलिए हेलो सर बोलिए हाँ बोलिए सर
all the participants are aware about the rules and regulations because it's a fair show for everyone. 15 minutes, we would be shortlisting person after around 10, 12, and request all the members to ask them two questions, and the rest of it we can actually take it offline, right? So all the best, and see you that stage.
Judges and fellow participants. I am Feroz and I'm here with my teammates Rahul and Firoz. We are currently pursuing third year artificial intelligence and data science department. We are here to present our ground idea, which is aquavision. These are the highlights of aquavision. We have many key factors in aquavision, which is basically not about only the plastics. We are basically connecting the dots between the plastic reduction and the final decision, which is cleaning the plastics. We have used AWS to deploy our models, and we have used multiple deep learning models. We have basically have done 5 deep learning models, and we have reassembled all the well profile models, and we have some other features in that which our teammates will be discovering. The main one is problem set. In problem set, if you see, plastic pollution is not a is not a plastic pollution is in our water bodies such as rivers and has reached alarming levels. This challenge is multifaceted. And if we come to the solution, community building aquariums. We have built community and we have engaged non-governmental organizations, and we have include aquariums, which is basically community to have a chat between the individuals from different parts of the world. This is the architecture which Rahul will now explain.
As you explained about this, here are some general models aspects. It's contained mainly two parts. First one is experimentation and pipeline. It includes data collection and exploratory data analysis to understand our images. And we performed data validation and reduced our images to around 600 images. And we have annotated each of the images into different categories like plastic bottles, plastic bags, like that. And we have augmented the images so that we got around 10,000 images for training. And we have used Collab and Kaggle to train our models parallelly. And we have continuously evaluated and validated our model and performed hyperparameter tuning based on the model's performance. And at the last iteration, we have stored our code and models in a GitHub repo for deployment. Deployment pipeline, we have used an AWS EC2 instance to deploy our Flask server that interacts with the users. It basically accepts two types of inputs. One is images and another one is videos. Users can pass their images and videos to our models. In return, our models returns predictions of our models to EC2 instance. And then we have an output monitoring system. This output monitoring system continuously monitors the outputs of our models. And if our models accuracy drops under a predefined threshold, it triggers a rewrite. And we also have few other components like explainability and community alerts and reports. We will discuss about it later. And here is our models architecture, and here are the models we have used. Let me explain. We have basically three architectures: single class, multi-class, and API architectures. In single class architectures, we have used four different models: fast RCNN, YOLO V8, YOLO NAS, and Ritter. And just detection transformers. Actually, we have here the inputs and trained each of the models without hyperparameter tuning. We got around 40 to 60 MAP, and we tried hyperparameter tuning to these three models. We rejected detection transformer due to its complexity, and it took so long to train actually. So we rejected it, and we ensembled actually we performed a hyperparameter tuning, and we
safety. And for multi-class architecture, we have used two models, YOLO V8 and faster RCNN. Actually, multi-class architecture is for detecting plastics, of different classes, like plastic plates, plastic bags, like that. And we have decided to use faster RCNN because YOLO V8 didn't perform well. Because it got about 29 in UP, I think so. And for APO options, we have explored two options: RoboFlow and teachable machines. These both were multi-class classification models, and they didn't also perform well, so we didn't incorporate them with our project. And without including this, we have another architecture that detects stationary and moving plastics. We used fast YOLO V8 to train our models to detect stationary and moving plastic. It's under development and but works fine. And here are our results of single class prediction, faster RCNN, YOLO NAS, and ensemble of weighted box fusion. And here is multi-class predictions. It's not here, I think so. Okay, here are API predictions that says RoboFlow, that's for RoboFlow, and we got a 13. Now let me explain in detail about the features in our platform. The first section is detect and discover. The detect and discover is the first section of our platform. It is visible after the login. This is the area where we can upload an image or a video, or even take an image for predictions. This section has an explainable AI feature where it explains about the counts of plastics in that image and the categories it has found and whether it is moving or stationary. We have used ChatGPT API and carefully prompt engineer. We also collect the geolocation data of the user for further use in the upcoming sections. We are displaying the three results. One is just the counts of the plastic, and next one is the category counts such as styrofoam plates or plastic bottles, plastic plates, such like that. We are categorizing up to 9 classes. That's it in the detect and discover section. Let's move on to the next section. This is how our interface looks. We have select image option, take image option, and predict option. In select image, we can select an image or a video. It displays the output there. And take image, we can take the camera and just take a click, and it will display the result there. And this is the explainable image. This is how it looks. Next. And aqua variants. We are detecting plastics, but what is the use of it? We need to connect NGOs and governmental organizations together to clean up the plastics. So we have led to the introduction of the aqua variant sections. In this, when a user uploads an image for a prediction, the email and SMS is sent to the nearby NGOs and governmental agencies. The question might arise: how we are approaching the nearby NGOs and governmental agencies? During the time of the register, we will collect the location of the NGOs, but which by that, when the user uploads an image for prediction, we will also get the location of that user. By using an algorithm, we will calculate the location of the NGO and the user, and we will send the SMS and mail. We will send counts of the plastic, geolocation link, which pinpoints the exact location of the plastic. Next, right? This is how it looks. We will send email and SMS for the NGO for an instant alert of where the plastic is detected. As you can see, the area, count, and the geolocation link. When we click that, it points to the Google map where the exact location can be found. Next. Whenever a prediction is made, the details will be logged in the aqua variant section. As you can see, it displays city, state, geotag, plastic count, time, and predicted image explainable AI. Any user, we have implemented user management system, which effectively manages every user. So every predictions are logged here. It is publicly visible. And we have granted a special access to the NGOs. When they logged in, there will be a tick option. When they click that, the pending request will be moved to the completed request. The option is only available for the NGOs and governmental agencies. We can apply various filters like city, state, and pending or completed, and we can filter out where the plastics have been cleaned and where it is pending. So this is about Aqua Guarding section. The next one is Aqua Insights Hub. Aqua Insights Hub. This is we have it. We don't have a tool to generate a report. We need a tool to make decisions and reports. That's why we have developed this Aqua Insights Hub. This is developed using Streamlit. You can find all the information regarding the predictions made. As you can see, this is just the sample data we have implemented because we have generated. This is only new, so we haven't generated any data. But when the new data is generated, it is going to add it. This data is taken from the past collections. So as you can see, the various states and cities, the heat map is displayed. And here is the plastic category distribution, region-wise plastic count, and overtime plastic growth category. Aqualize. In a multifunctional platform where the various users engage, we need a place for the users to discuss and share their feedback. So we have developed the Aqualize. It is a common social platform where a user can share their thoughts and like comments and reply their posts.
We have implemented all of the model in AWS EC2 instance. And if you can see this architecture, we use the private key to connect to the EC2 instance from our local computers. For this, the file transfer will be smoother. And why Aquavision? Why should we use Aquavision? Aquavision basically provides you all the features in which by using Aquavision you can get all the insights and all the data from where the plastics are detected.
Thank you. It's my computer. Thank you, Syntax Layers, for setting the tone with your thrilling presentation. Your passion and dedication are truly commendable. Kyndryl is all set to join us, ready to dazzle with their groundbreaking ideas and expertise. Let's give it up for them.
So do you
We
want
are
to
open
present?
for a Q&A session for Team Syntax Layers before we move on to the next presentation.
We will talk about identifying moving displacement plastics. What is the accuracy of identifying these plastics that are emitting? The geolocation will keep changing. Needs. We talk of using that probably where it's not a question. So you talked about yeah, this one. This is the first.
Actually, geolocation we are working on it, sir. We are working on the geolocation part, sir. But we have no this difficulty, sir, and we have also as another difficulty, which is underneath the plastics below the surface of the river. We have also addressed that. We are working on now. Within 1 month, we'll be completing those parts. Sir. We got an MAP for moving plastics about 52, sir.
Okay, so you have addressed one good problem, but I like your security also. But one thing is you have put it on Amazon. So one dependency is always must be connected to Amazon. Otherwise, I cannot upload. So this will be a real-time problem. So I'll be watching. I'll be putting the static camera, or somebody can take a photo and upload it.
So you are asking somebody to upload it with a specified one. There is no collective kind of thing where you just throw it there and it will be immediately shifted to somebody else. That is not, you are getting the problem. It is not real time. As of now, somebody has to take a photo or upload it, or take a video and upload it. By that time, plastic might have moved. How are you addressing that? Have you seen through this, or it was not thought through?
Actually, we have seen through this, sir. We have decided to implement few cameras near rivers and other places, sir, so that it can monitor in real time and work in real time. So we can modify and scale this for real time usage also, sir. It's just a prototype that we can. Thank you. Thank you.
Next up, we have Team Kiernan's Kyndryl.
So you want us to present from our slides, or you want to open? Oh, am I audible?
Team Kiernans, you can start with your presentation. Make sure your mics are on.
Yeah, let me start in. Yeah, can see my screen? Can see our slides?
Yes, you can please continue.
Yeah. Good afternoon, everyone. I am Janardhan from Keenan's team. So let me introduce my team members first. So with me is Tommy Sam, Isaac Cheng, and Sam Turner. So unfortunately, Isaac and Sam could not join today. So we are, as can be seen, we are 4 Kyndryls from ANZ Apps Data and AI Practice. And we are teaming up as Keenans to honor the effort of Ian Keenans to cleaning up the world. So firstly, the solution summary. Our solution is comprised of 5 components. So as can be seen in this one, we have deployed part of the components on the cloud and part of the components on devices, and we are also proposing an edge device. So I will go through those. We will go through those slides, those components in detail in the subsequent slides. Firstly, the challenges behind the model development and solutions are fourfold. So as can be seen, the image is big. So the contemporary camera technology can take a very high resolution image, um, and also they can cover larger area. So this causes the plastic debris to be small. Like obviously in nature, the plastic debris are small, and when the bigger area is covered in the image, plastic debris is still going to be even smaller. On the other hand, the background is busy. So the river are full of river is full of with plastic patches and other organic parts. So most importantly, we also have to come up with a sustainable solution. We are solving a sustainability problem, so it is very obvious that our solution has to be sustainable as well. So our idea was simple. So what we do is to overcome the challenges. What we do, we split the image into multiple patches. So as can be seen in this diagram, we during the training and validation process, we split the images into multiple patches and train the model. So when we split the image also, we resize into multiple resolution as well as split into multiple size tiles in order to improve the aspect ratio, in order to improve the robustness of the model. And we also employ augmentations to further make the model more generalized. Similarly, during the inferencing, we resize the original image and split into multiple patches. Then we form as batch and perform the inferencing against the trained model and get the detections for each patches. And then we combine the results to obtain a final detections for the whole image. And we also keep an overlap to make the objects combined. So that helps us to make the not to make the duplicate detection for the same object. So if we developed two versions of the model. The first version is performed with 86.25% average recall. And the model, as you can see that our model is only consumes 3.8 million parameters and 8.7 billion flops, and also only take 11.5 megabytes. And also our framework can handle higher resolution. So obviously we developed the, we use the YOLO V8, we fine-tune the YOLO V8 nano model for this. So with these properties, our model is deployable on resource-constrained devices. And also we have tested our model on the Raspberry Pi device, or Raspberry Pi 4, and it only took 10 to 12 seconds to predict the whole image in this high resolution. So the version 2 model, we have further, we have employed rigorous update augmentations, which even made the model more robust and more generalized, and which helped to improve the accuracy to 87.83% average recall, which is 1.58% higher. And we should thank our mentors, Saurabh and Javed, for helping us on this space to further improve our model. So this is the prototype design of our IoT device. So we are proposing Raspberry Pi based edge device comprising of a camera and the connectivity, and also a solar panel and battery powered device. So we also have developed a mobile application. So deploying our model into the mobile, we use the MAUI technology so that it is a multi-platform app. So a volunteer can use this app to take a photo of a river, perform detection on device, and submit the detection back to the server for further decision making or further action. So with that, I will hand it over to Tommy to discuss about our backend architecture.
Thank you, Jana. Now, for the next few slides, I'll be discussing our architecture approach, which we're able to implement 2 designs, and we've proposed a 3rd design as well. So our proposed architecture involves the use of Azure Stream Analytics. When a IoT edge device, such as like a Raspberry Pi or a mobile application, sends data to the cloud backend, the Azure IoT Hub will register the device the message is coming from and the message that's being sent. In this case, it'll be the detections. From here, the Stream Analytics service will receive and store messages sent where any sort of data transformations can be done directly via Power BI or through a custom dashboard. Moving on to the next slide, the second solution shares a similar methodology. Sorry, Jana, could you move to the next slide? Cheers. Sorry, one before that. Yep, so the second solution shares a similar methodology. However, messages received by IoT Hub will be sent directly to the Azure Data Lake. The data will be processed and transformed in batches through Synapse pipelines, either hourly or through like a daily schedule, making it simpler for the data analysts and allow them to focus just on visualizing the data. This is a more cost-efficient approach where there is less of a requirement to trace detected plastics in real time. And lastly, to break down costs further, we can use Azure Functions to move your data across and perform additional data processing steps, such as transforming the detections to include weather information or tidal information, or perhaps detecting the movements of plastics as well. And using Azure Functions would make it significantly cheaper to work with, as you would only pay for the time Azure Functions is running. And I also want to point out that with the services that we've considered, they're easily translatable across other cloud vendors. And we've tried to consider a cloud agnostic solution where we could just make the switch if Azure is not a preference as well. Now, moving on to our dashboard design on the next slide. So in the early stages of our solution, we ended up creating a report using Power BI. However, this does come with licensing implications, which Jana will talk about later within the presentation, about a custom dashboard later. So the first page of our report contains a high-level summary of detections which individuals can change the view by just simply selecting location. The aim is just to have a summary of significant figures corresponding to the location, which a user can just simply look through. And on the following page, monthly detections are shown to identify trends or periods where cleanups should be performed for a location. On this slide here, we can see a further breakdown of the monthly detections. So from here, users could see the distribution of plastics by seasonality, and other visualizations that could be added here in detail could be the influence of weather forecasting or drift detection, which we've briefly covered before. And lastly, we have a page for daily detections as well, which users can observe the volume of plastics detected at different times of the day. Having a view like this would just support a low-cost solution where detections are often observed. And now I'll hand it back to Jana to discuss how these ideas could be implemented without the use of a licensed solution like Power BI.
Thanks, Tommy. So as Tommy mentioned, so the Power BI is coming up with the cost as well. So although we can deliver the reports faster and develop and deliver faster, it comes with the cost. So we considered another alternative. So we have developed a very interactive custom dashboard using the technologies like cross filter, D3JS and DCJS. So we also have developed a mockup data to just to make the data to bank. And with this, we can replace the Power BI with a similar functionalities. So our aim is to deliver for reports quickly with the Power BI, and down the line we convert it to custom dashboards. So that will help to reduce the cost. The scalability of the solution, obviously our solution is scalable in every component. Firstly, the IoT edge device, we propose a standalone device powered by solar. So, and also it performs inferencing on device, so it can be scalable. Then similarly, the crowdsourcing mobile app. So we are trying to leverage the power of the mobile device, which everyone have in these days in their hand. So they are independently scalable. And then the Azure cloud, obviously the cloud technologies are designed to scale. So our solution is independently scalable.
Team Kerlans, you have 2 more minutes to wrap up.
Yeah, thank you. Then the sustainability of the solution, our model is very lightweight so that it can be deployed on a device which with a very small carbon footprint also. And also the hardware is very small. Then the IoT edge device. So obviously it is powered by solar panel, so no more emission. And the smartphone app, we tend to reuse the existing platform. Then we also use the cloud technology very carefully. we try to minimize the technology as much as possible while achieving the functional requirements. Then our innovation of our solution is also mostly summarizes our 5 components. Firstly, we proposed an efficient yet commercially viable model. Then the standalone cost-effective hardware for image capturing and inferencing, and crowdsourcing solutions to involve everyone, and a lean backend solution on Azure services with minimal deployment effort, development effort and cost. And also we developed multiple dashboards using Power BI as well as tailored custom dashboards. So that's all from us. And if you have any questions.
Thank you, Team Kernels. We are open for questions.
Is you already made your model viable to be deployed on edge devices. So if that's the case, what's the need for going a heavy cloud architecture, specifically for cloud services? So it is possible for us to do something, especially inferencing on the edge device. Only the edge device data, the output data, which says that this image contains this much of plastic, only a teeny information can go rather than sending the whole image and things like that. Is there any rationale for that? We can give rationale. That's the first question. The second question is basically this will be an operational thing. We will observe, we will infer do something. But when you are showing the dashboard, I didn't see any recommendation, what has been done, it has been observed, what action has been done. That would have been much better. Because that was the expectation when I heard Kyndryl team is also participating.
Yeah, actually, I cannot clearly hear the first part of the question, but for the second part of the question, actually, we lag in that. And however, the solution, the technology selection is already having that. The Power BI can generate a report. So our impression was sending the reports periodically to for decision making. So I think we missed to mention it, but that was our assumption. And the first question I cannot clearly hear. If you can, someone can summarize it.
Yeah, the first question basically is why is it a heavy infrastructure on cloud when the inference can be done on the edge device?
We thought that our sustainable solution. So usually the hardware required in the cloud in the central place to process everything would take. There will be two impact. It might make costly, the solution costly, and other one is to it might emit more. So this one is like we use the hardware to the maximum level to reduce the cost as well as the sustainable. So that was our decision. That was our reason behind the decision.
Sorry. Basically, I felt with that heavy hardware, the possibility of moving from avoiding plastic to getting into electromagnetic waves of 5G. That will be another hackathon. That should not be. So you have a good solution in the edge. So you can send only 1 KB of data instead of sending 10 MB of data of images and other things. So it reduces the bandwidth by 90%. Thank you.
Yes, that's also the other thing. Like it makes our solution more feasible, so that it can be deployed everywhere. And anyway, we have to mount the camera on the reverse side. So our lean hardware would be a little bit more addition in terms of cost.
Yeah, the question that I have is, in your technical architecture, you're breaking down the images into patches and then you're doing the training. And then again for inference, you're breaking it down into patches and doing the inference. And what is the reasoning behind breaking down into patches when you can just do it without breaking the images into any patches? You can straight away do the inference on the images. What is the reasoning behind breaking down into patches?
So actually, when we test with the whole image in such a small model, it only yielded like 30 mean average precision. But when we take this approach, it went up to 75 MAP. So yeah, the accuracy was high after we take this approach.
Second thing is you've deployed your model in the mobile. So, what are the quantization techniques which you have employed for reducing the size of the model? Have you employed any quantization techniques or
But we explored, but the problem was like we had to submit our ONNX model. That the ONNX model was like the framework the YOLO V8 integrated one doesn't support the quantization. So we didn't explore much, but we explored the other one is neural magic kind of thing. So that can so in a real deployment we will go instead of or in the next kind of thing, we'll go with the neural magic to quantize, and even we also can perform quantization aware training and all to further reduce the one. So that one still will improve our model efficiency.
Thank you, Tim Kyndryl, for sharing your innovative ideas with us. Your vision is an inspiration to us all. Hold on to your seats. Team Solo GSM storms in with a presentation that promises to be nothing short of spectacular. Let's give it up for them, everybody.
Thank you, everyone.
Stage. Studying.
Good afternoon, everyone. My name is Shyam.
Little.
Yeah. First of all, I'd like to thank the organizers and jury members for giving me this opportunity to present my solution on hackathon of plastic-free rivers. First I'll brief introduction of my team and then talk about solution summary, architecture, innovation, scalability of my prototype, and then do a demonstration and talk about substantive business value of my solution, and finally conclude with summary and future scope. Yeah, I'm only the team member who participated in this hackathon to build end-to-end solution, and I have 12 years of experience in software development. I'm a technical lead, and also I'm pursuing a master's in race. Regarding the solution summary, I use YOLO V8 for object detection and a slicing agent hyper inference technique for improve the model detection accuracy, and use enhance the performance model by using effective annotation and annotation technique, and by using geotagging by extracting the GPS information from the image, thereby can locate the plastic pollution locations on the map. And I use performance metrics as mean average precision. The standard difference I got around 0.071 MAP on trained dataset and 0.67 on MAP on test dataset. And also, I reduced the inference time by 3 times of previous model by using the lighter version of YOLO model. And I use a new technique developed an algorithm which works on object detection inference by slicing the high resolution image into a small patches and do inference on the enlarged version of patch to do a better detection and thereby achieve a MAP of 0.803, which is 12% higher than the standard inference. And also I developed a user interface to easy to interaction with my system. And this is the architecture of my system. It consists of a browser where the user can upload image and video to the screen read server. So once the same server receives the file, it will pre-process the image and then send to the plastic detection module where it detects the plastic and pre-process the results from the product detection module and also send to the geotag module to extract the geotag information and mapping module to plot the plastic location pollution location on the map and the telegram notification module to send the notification to the concerned team to counter the plastic collection and counter module is to count the plastic detection and heat map visualization to view the heat map density of the plastic on map. And these are text that I use for data pre-processing. I use RoboFlow for annotation and augmentation techniques, and I use YOLO V8 and slice YOLO and slicing and hyperinference for object detection and inference. And I also built a detection alert priority model which classifies the severity of the detection by using a k-means clustering and also use a free GPU execution environment by Google and Kyndryl. For the model deployment, I use a Streamlit Web UI framework and Telegram API to send detection image and detection result to the Telegram channel. As a part of deployment, I use a Docker for faster and easy to maintain the deployment process. Come to innovation and scalability of my prototype to minimize labeling tasks for large data set. I use auto annotation technique by using by building a base model with a small data set around 30 images, and then it also enables me to quick prototyping and do validation on the solution. And I also improve the model iteratively by using more data and refine technique by using slicing and hyper inference to improve the model performance. And I use the geotagging for the image tracking. And also I built a machine learning based detection alert priority system which classifies the detections and notify the user as high, medium, and low so that we can take necessary action to send that image to the concerned team by using a Telegram channel. There's also I had created Telegram channel with only subscribed users can see those messages in that channel. And also I built a easy to use web UI interface and by using a push notification to Telegram for this cost effective solution to notify the team who takes next actions. And also I packaged up the application by using containerizing the Docker for easy deployment, and you can easily scale up in the cloud like Google, AWS, and by using the Kubernetes clusters. And this is the UI of my application. This is the home page. Just give brief introduction about this project. And this is the next page. This is the main page. So passive detection. User has to First user has to upload. First user has to select what kind of a device they are going to inference, and then can select image or a video. Once you select image, it will be shown. User can upload files, and also user and the uploaded file can be visible on the right side. Yeah, and also user can control the detection threshold for the detection. And also user can select multiple the classes types to detection, and also can select inference type is a standard inference or a slicing aided hyper inference. Also can user set the input image height and the width. Then once the user click on detect button, it will show the detect image on the right side, and also it show the how many plastic count in that image along with the inference speed in seconds, and also ML-based model predict the based on the location and the classic density, will show the priority of that detection, so that user can take a necessary action by publishing the message in the Telegram channel. And also, you can see on the right side of the mobile app, you can see the detection image along with the results in the note on the Telegram channel. And user can also download the high resolution images from this application. Yes, once the image is detected, that also can be plotted by using the geotag information on the map, and same can be visible in the mobile app as well by clicking that link provided in the message, the notification message. User can also upload a video to track the plastic along with the ID and the track path using the red color. And user can also view and download the results from the these are results, the file name, date and time of the image taken. These are metadata of the image, the number of plastic count, latitude, longitude, and the address. I did just a geostory for that to get the address, and then the geotag URL to view. By using the geotag URL, you can view the map, external map, another browser window, and also can be seen in the mobile app browser as well. And also user can upload the results which we download from the previous detection page, and also you view on this heat map page, and also can visualize the heat map density on the heat map. That will be the red color will be the higher density of the plastic in that area, and the greener will be the less. Yeah. So the sustainability of my solution, to combat to minimize the carbon footprint on environment, I use a different technique by using compute efficient, data efficient, and some good practices. As a part of compute efficient, to reduce the model parameters and computation during training and inference, I use Euro's nano and small architecture, and use 16-bit floating points of precision to reduce the model weight size. And also, I use a slicing added inference technique to improve the model accuracy without training new data set. And as a data efficient, I use just 137 images for model training, and I use auto annotation to build auto annotation model. I use a semi-supervised learning by annotate the first 30 images, and then that model is used to label 200 unlabeled data. And also, I use the previous training model on new to train a new data set by leveraging that transfer learning technique. And I use the good practice to minimize the usage of hardware resources. I use the Tesla T4 energy efficient GPU, and a GPU on Google and Calab Cloud neuron instead of on premises. And also I use a small model for deployment, and I use Docker for efficient deployment and lifecycle management. And also it means for faster development, I use all open source and free software. From the business value of my solution, it reduces the labor cost and improving the operation efficiency by automating the plastic detection process. And also by using the sustainability practices, it demonstrates the environmental responsibility and also helps in the business for effective manage the plastic waste and also thereby it enhance their reputation of their social responsibility. And in summary, my solution demonstrates the scalability, transfer learning technique, flexible deployment options, along with the geotagging of an interactive images. And also, it shows the positive impact on the environment by offering the cost and time efficiency, and also it enhances the business reputation. Overall, my solution shows a good potential on combating the plastic pollution. As a future scope, I'm planning to improve the model detection and recognition by using advanced generative AI models like GAN and diffusion models. And to automate the plastic collection process by using drones and robots, use advanced object detection techniques like optical distance calculation, radar, and GPS. We can also enhance the object automate the collection process, and also planning to develop a RESTful APIs with to integrate the external system and to promote modularity and extensibility of my architecture.
Thank you, Team Solo GSM. We are open for Q&A sessions.
Right, thanks. So one question is, when you create a user interface, you expect that the user to choose whether to use GPUs or CPUs. So what is the intention behind it?
Yeah.
And what does that, if I choose CPU versus GPU, what is the impact on the image resolution or the inference?
Yes. There's a trade-off between the accuracy and the performance. If you use
So I understand why you have to use, why does the end user have to select the GPU or CPU? Because you're simply uploading the model, I mean, uploading the image.
Yes, these are semi-automated process actually. It's not a fully automated process. I did not create any pipeline in the backend actually. So for the real-time detection, we need a GPU environment basically. Because when we see my detection with the OS model, it's a CPU inference is only 2 seconds for one image actually. To parts of the inference time, I gave that option.
Who will pay for that?
Sorry?
Who will pay for the selection of GPU versus CPU?
Then it depends on our deployment on the cloud. If you use cloud GPU, then definitely we can select it here. But and also I made if only GPU available in the system, then only get that option. GPU option will be available. Other will be disabled by default. And background checking whether system has GPU or CPU.
Yeah, the extension of that question, use of AI should be to reduce any kind of complexity. Like what LangChain has done for any GPT, it has increased the complexity. Are we giving everything to the client or the end user? 10 people will start, I want GPU, I want CPU from the same client. So will that be reduction of the complexity? And if it can be done in CPU, but client wants GPU, he selects it. Who selects it? Who will pay for that is the question. These are the two questions. Are we reducing the complexity or we reduce the cost and increasing the performance?
Yeah, we have to minimize the user interactions by automating the process.
Atlantic Warriors takes the stage now, bringing a tidal wave of innovation and brilliance that you won't want to miss. Let's give it up for Atlantic Warriors.
Change this work later. Hello, respected sir and ma'am. Hello. Hello, respected sir and ma'am. We are the team Atlantic Warriors, and we are really excited to share with you the solution that we have come up with in order to detect what plastic and to use the innovative technologies powered by deep learning.
Okay. So the agenda for this presentation to provide a brief overview about the solution, giving the architecture of the prototype and providing the innovative and scalable product, and defining the sustainable future towards the plastic pollution reduction. So let me introduce myself. Hello, I'm Sarthak Kaparia. I'm final year student at Pandit J. Energy University, Gujarat. This is my teammate Berangi Mehta, and we both are a AI/ML tech enthusiasts. And we are grateful to Kyndryl and REVA University for providing this amazing opportunity for that help us to contribute to two main goals that we learned about is technology and environment. We would also like to appreciate the mentoring given to us by Dr. Ratnakar Pandey sir.
So, plastic, once hailed as a revolutionary invention, has now become a silent adversary, invading our waterways and killing our marine ecosystem. To tackle this issue and to give a response as well as to motivate everyone to take pro-creative steps to a healthier and cleaner life, we would now like to present our solution to you. First of all, we have identified three main areas in the problem statement that we would like to discuss.
Lack of awareness. Many people are unaware about how quickly plastic will spread and harm the environment. So we need to take care of it and address towards it.
Need of the hour. It is a high time that we start using advanced technologies and stop using the traditional methods that are used to monitor and quantify the plastic because they are time consuming, cost effective, they are not cost effective, and they lack precision. So we would like to show a solution that can combat these issues.
Sustainability a priority. The solution architecture should be efficient, impactful, and easy to use in order to reduce the pollution and make less carbon footprint.
As you can see, our solution has been divided into four different types. The model, the database that we have used, the user-friendly interface that we have created and deployed, as well as some visualization tools. For the model, we implemented various state-of-the-art architecture like Fastwell CNN, YOLO V8, and detect prompt. But we found YOLO V8 to be most efficient and faster inference time, as it was able to boost the productivity as well as give a flexible approach to the solution. The database that we have used is the MySQL database, which is a very structured query language, as well as it is very secure and efficient. And we have normalized this database to BCNF. For ease of access, we have developed a user-friendly tool which helps us to that was deployed on Azure App Services and Docker. Uh, in order to, regardless of the technical expertise, user can upload the image on the web page and get the result as soon as possible. We have also used some visualization tools to convert the raw data into a meaningful visual so that a user can get knowledge efficiently. As you can see, this is the solution architecture. And as you can see, there are two different ways the user can input their image on our web application front end. And user will get an output in all of the three mediums. The data that they have uploaded will be displayed on a dashboard along with some visualizations to help them. And the main part is the number of plastic that is detected. And our whole application has a Flask as the architecture in the backend and the MySQL database. Along with that, we have used Docker and GitHub Actions to deploy it on Azure App Service. For the model, we have used YOLO V8, and that was trained on Azure Machine Learning Services. We used the annotated dataset and we annotated it using RoboFlow. With the help of Azure notebooks and Azure compute instances, we developed a ONX runtime inference model that provide a inference speed of around 5 to 6 seconds. We would like to give you a small demo of our application that we have generated. As you can see, this is the landing page of our website. As you can see, we are Team Atlantic Warriors. These are the services that we provide, and these are some of the testimonials that our friends have provided after using our app. So user can operate all the applications once they have logged in. This is their dashboard, and they can easily go to any service. Let's start by detecting the plastic. A user can choose any image that they need to enter, and once they submit the image, we will get the detected results as an annotated image that will be generated, along with taking the metadata of lat and long that is provided. We have also pinpointed the exact address location that we would be showing. And image, and we have shown here the exact object count as well as the exact location that is that the image is corresponding to. We have also ensured a user feedback system where they can tell us that what's the if the image is good or bad. And once they submit anything, we have a model where if it exceeds a negative threshold of some value, it will trigger a retrain of the models. Along with that, we are also along with
consume their own water. So it is a not a huge economical incentive that we create for the industry themselves. There are a lot of clever techniques that we can use. Thanks again.
Thank you so much.
Thank you to New York Todd. Next up, we have Team Eco Guards. Let's give a big round of applause for Team Eco Guards.
Good evening, everyone. Good evening, everyone. We are Team EcoGuards, and we are here to present our solution on hackathon on plastic-free rivers. Before diving into our details of the project, here's the agenda for today. Next, let's introduce the brilliant mind behind EcoGuards. So, handle API request. As you can see, this is the docs of Fast API. Next, we have also integrated Dropbox, which is reliable and secure cloud storage solution, which is required because user uploads an extensive image dataset, and you can see the elements inside the Dropbox. Next, we have statistics on plastic counts, which are total plastics, moving plastics, and stationary plastics as well. And we have extracted the location from the image metadata. Uh, in the map section, we have an interactive map which shows the cluster of plastics and a visual. It is a visual representation of plastic locations, and the users can also obtain directions, like specific directions to those plastics which the user has selected. Further elaborating on the maps, we have location prediction, which is in the slide you can see there is a slider which represents the amount of time for forecasting of the location of plastic, which will be elaborated further in the PPT. Next, we have a history section, which is a crucial part of our project, and it is invaluable for trend analysis and decision making. So basically, it has all the latitude, longitude, counts of plastic, and the timestamp as well to make further analysis of data. Next, we move on to the statistics section. In the statistics section, we provide in-depth statistical insights. This is a temporary data set which we use because we don't have the data set. As the user base increases for our website, we can introduce the website which the user creates by himself. So I have explained about the website. Abhinda, what do you think?
So I would have a little biased opinion here, but the website really allows you to dive deep into the whole prediction and detection and also allows you to see the statistics. But personally, I am on the go a lot and would like a mobile solution. That's why we developed the companion mobile application, which simply allows you to take a photo from your mobile phone and upload it. You'll also get the annotated image and the plastic count along with the location. Thing here is that the model was trained on aerial images, but with mobile phones, you would be able to take like drone-like images. That's why we also had to adapt our model. So now, talking about the object detection model, it's the takes the most prominence in our whole thing. So that's why we use the YOLO model because of its like time object detection capabilities. Also, we trained it on Kaggle using different data sets. So here, like YOLO offers different segments like X and an M. Our solution included using two models, taking the output, combining the results to create this robust and accurate model. So this is like just the result of one single YOLO model there. On the Saigon model, the X model performed like a league above. In phase two, we used like the annotations, like annotated image and augmented our data sets trained two separate models on two separate subsets of the same data set, which is Saigon. But in phase three, we knew we had to do something groundbreaking. That's why we trained two separate models. One, which gave the best results on singular, the Saigon data set, and second model, which gave the best results on the general plastic data sets. And we created the most accurate and precise model we could till now. Talking about this general plastic data set I was talking about. So basically, we gathered about 26,000 annotated image of general plastic. But it would have been a computational nightmare to train a model on like such high data. That's why we used k-means clustering to essentially eliminate the similar looking images to acquire a rich and diverse data set while reducing the computational cost. Uh, these are like the most apt representation of our current solution, where as you can see, the model is able to identify different types of plastic, different colors of plastics and on different angles, and not just the Saigon data set. Now, Manav, can you carry on with what's the result of the 2 months worth of brainstorming?
Yes. So to sum up our project, I will explain the architecture of our project, which starts with first the sign-in using Dropbox. We chose Dropbox because first it provides us with some amount of free storage and is also a user-friendly way to authenticate our users. Once the user signs in using Dropbox, they can access our core pipeline in three ways. That is either using mobile or single images by using our website, or even bulk upload images to Dropbox. The idea behind was that the drones can upload multiple images on the Dropbox directly, and from there we can bulk process these images. Once we receive the images, we applied certain sets of pre-processing, which I will explain much more in the next slide. However, once the image pre-process we have received, it goes to the two ensemble models, the general model and the Saigon model. The results are combined and then ultimately stored in the Dropbox storage. So the image pre-processing. So before applying any image pre-processing, we first check whether the image was clicked by drone or not. For doing so, we check the metadata, particularly the device type and device make and model, to check if the image was actually clicked by a drone or not. Once we establish that the image was clicked by a drone, we apply our two pre-processing techniques, that is segmentation and glare removal. So let's consider this image on the right. So now we know that if that this image is by a drone by checking the device make DGI. So let's start with segmentation. We want to first segment the image to identify any moving plastic. We first convert the image into grayscale. We apply Gaussian blur to reduce some amount of noise. Now ultimately we want to detect the largest contour in the image. For the contour accept only binary images, and we want our solution to be universal. So instead of simply thresholding on the green part, that is we can simply threshold by selecting on green images. Instead we use Canyon detection. After applying Canyon detection, we use the morphological close operations to fill in the small holes, and then finally apply contours. This way, we are able to detect the largest contour, which detects which resembles the largest piece of land. After multiple trial and error, which we decided upon one particular green color, so that our model doesn't get confused by looking at this image. Now, these are the sum of segmentation results, which are quite good. So now onto the glare removal. Glare removal is particularly tricky because there are different shapes, sizes of glare. But one thing which we can all agree on is that glare is always white. So we start. For example, in this image, we can see that there is a glare on top left. So first we convert it into grayscale, and now since we know that we are interested in a white object, we threshold the image to detect all the white objects in the image. But since our main goal is plastic detection, the plastic itself can also be white, and we do not want to reduce the count of plastic, as seen in this threshold image. So through our naked eye, we can see that most of the time the glare is circular. So we find the circularity of this contour by using the formula 4 pi area by perimeter square. But to our surprise, we found that circularity was only 0.063, but instead it should have been closer to 1. This was because the contour edges was quite rough. So now we can clearly see that the white object at the top left is the glare. But how do we pinpoint that that is exactly the glare?
So one more thing which we noticed that if the glare is present in the image, then it is the largest white object present. So we calculate the area of all. We plot a bounding box on the contour, that is the green bounding box. We calculate its area, that is the area of rectangle width into height. And for this particular image, we found it to be almost 46,000. But what about the images where glare is not present at all? So upon trial and testing, we found that the we set one more criteria of minimum area, that is 7,400. So these are some of the successful images. So as we can see on top right image, there is no glare, and in the middle one also, but none of the plastic got masked by mistake. So now that we are almost covered with our project, what do you think, Anurag? How are we separate from our competition?
So that's a great question, Manav. So firstly, we have tackled the glare removal from the aerial view data, which helps us detecting plastics even in tricky lighting conditions. Secondly, a model excels in identifying both moving plastic or static plastic with precision. Thirdly, we provide detailed statistics offering valuable insights ranging from plastic counts to information matrix. We also provide simplifying complex data by helping user visualize the complex data into the number of plastics in an area along with the cardinality within each cluster. So we also recognize the importance of historical data, and hence a solution enables user journey through time by reviewing past detected plastics. Lastly, a geospatial prediction reveals precise location of the plastic given in the image. So in addition to the innovative features, the future location of plastic is also pivotal for effective cleaning. So we do this by taking into the factors of the speed and direction of the wind, the tidal height, the wave periods, and its time interval. So we aggregate all the influencing factors and do some advanced mathematics to get the future predictions. So in order to ensure that the accuracy meets its demand, we include geospatial data, which can be seen on the image left, on the image left, which represents all the river bodies in Vietnam. So we map the our location with the closest river feature, enhancing a prediction of future location of the plastic prediction. So moving on, our scalability of a solution effortlessly enables user to bulk upload or single upload images. It also uh, in, it also we also prioritize diversification, tailoring our services to both website application and mobile application. Our streamlined data processing along with Ensemble approach enables real-time plastic detection. And yes, our code base is pretty much simple. Using Flutter for mobile apps, HTML, CSS for a front end deployed on Netlify, and our core logic on Python, along with the models deployed on Azure. So moving on to the okay. So let's start with the live demonstration.
Since we are short on time, we'll just play this demonstration in the background while we can take some questions. We upload single images. This is the moving count, total count stationary. This is our mobile where we upload our images. And again, we can see the location. And this is the bulk upload. Here we can put multiple images. And on our fast API, we can call this API, and on bulk, the Dropbox images will be processed, expanding our history. Then this is the history section where we are showing all of our images, that is even all plastic, segmented, glare removal, and we can also see the Google Maps image. And we are also storing with time, so later on as we have enough data, we can also use some predictive model. This is the statistics tab and the maps. Here also we can get direction and go to the nearest point. Here we are used dbScan to cluster the images, cluster the plastic point. So the largest number of plastic within the 300 meter, and this is the future prediction. So after 2 hours, we predicted that it will be over here. Thank you.
Thank you, Team EcoGuards.
So when you precondition the images with k-means, already you detect certain features. Which of those features have been used by subsequent model? General classic model. But we wanted, but as per our previous suggestion, we also wanted to focus on general plastic, so that we are able to classify different types of plastic on different areas. So we tested out some in Google, but I was trained on Saigon. We counted approx 25,000 images from the internet freely. But training 25,000 images was actually taking quite a lot of time. So we also noticed that out of the 25,000 images, we five of them are similar to each other. So we grouped similar, so we clustered those similar images, and out of that, so we made 40 clusters using KV, and out of these each 40 clusters we selected only particular number of images, and by the end we had 6,000 images which were trained on those. So many clusters. On trial and testing, we manually employed for KV to cluster our images, divide our images into 40 different clusters. And it did quite a good job. We could see that similar images are in the same cluster. And
The images, many of the images, which is the data set we gathered, they itself they were augmented. Like one can be like this angle, another will be in this angle, but it would show the same. So we had to remove those. That's why we did the whole.
no, that's okay. That's okay. The question is, K-means already provides certain features. Record level features are already available. Right? Only the aspect level features will be determined by the deep learning models. Right? What are those features you could able to detect before? Because you said it's only for sampling. It solves the problem. Right? We are not use K-means for preconditioning. There's a good paper by the David which works on that. They say that preconditioning is everything.
In person,
This section is usually for the shortlisting part.
How is segmentation, how are you using segmentation for classifying stage median?
Like once we detected the segmentation and marked it, if the plastic detected it was on the segmented part, it would be marked as stationary plastic, and it was not on the segmented part, it would be detected as gold.
All the same image.
So we have two images which are given to a model. That is, first is the glare image, that is basically the original image. You can see the land and water as well. And then the second image is a segmented image where the land area is masked. So now that model detects whichever plastic will be automatically moving because it will be visible for it. So this way we are able to determine if the plastic is stationary or moving.
We have Team Saga who will be joining us online.
Hi everyone, shall we present now?
Yes, you can start with the presentation.
Hello everyone, this is Team Sagar and we'll be presenting our solution in online mode. So let's begin with our introduction. So I am MD Shahnaz Karim, a student from NIT Durgapur, and this is my teammate Gaurav Kumar Singh, and he is also from same college. Now first start with the flow diagram of our solution. So as it can be seen that drone images will be taken and stored in any hard disk like or any kind of internal storage. Now all the images will be passed through our main application, and our main application will process all the images. Now after processing all the images, the process data will be stored in two data frame. Now first data frame will contain the count and concentration of the plastic, and second data frame will contain nearest land from the water body, allow us to collaborate with the local workers of the nearest land. Also, it can allow us to collaborate with the local authorities. Now, the local authorities may can hire the local workers. Now, this way, this can be useful. Now, we will provide this geotag URL, which will be extracted through to the workers. Now, it will navigate them to the it will navigate them to the exact pinpoint that location from where the plastics need to be removed. We can directly provide it to the workers, or we can directly provide it to the local authority from the nearest layer. Now, let's demonstrate our prototype first. So this was our main screen, and after load image, when we click on the load button, it will allow us to select images. We can select multiple images, but for the sake of time, just now we are selecting 4 images simultaneously. Now, once we select the 4 images, we will click on the next button, and it will process the 4 images one by one. And here at the background, we can see that the images are processing, and we have tested with 120 images at the same time, and we have got no issue. So the images are processed. So let's click on one image, and as it can be seen that images are processed. And after that, there is one contact database. Now, this contact database is very much useful. This contact database is actually reading the CSV of the same folder. Now, how this contact database is useful, that we can enter the local authorities phone number, contact details, and address. Now, this will later be useful, or we can also, instead of local authority, we can directly add the workers. So now let's go to the generated result. Here we can see that all the images names are given, and also the plastic count is given, and also here the geotag URL is given, and also the nearest land. What is the nearest land? Like nearest land address, like it is village, town, or whatever it is, near that. Now, this will, as I mentioned earlier, that it will be useful to collaborate with the people and reduce the cost. Now, here I have shown the contact database. Now, this contact database, fetching with the contact database, it will give us the nearest local authorities contact number, or the nearest worker who is there. Now, since we are now this contact data that is we have used, this is for random. This is for just demonstration purpose. Once we got the number and once we get the geotag URL, we just copy it, and using Telegram or WhatsApp, we can share it to them. But we have not directly automate this process. The reason behind this is that machine cannot take decisions. That's why we want the final decision to be taken by the for example, if there is this image, and this image is nearest to that land, so the authority can take a decision to remove these plastics from the people or the worker from here, or and this from here. Now, after removing this, he can go to contact with them to remove this. Now, this way they can make a chain to reduce the time and the inference. Now, this is how this up to this our solution was. Now, but in the contact database, we can also add the contact number of the local industries, local plastic industries. Now, since they will be getting the how much concentration of the plastic there, and they will know that from where they need to exact remove, by giving this data and by giving the count, we can convince them to have a negotiation with us to give their some contribution to remove the plastic. Now, this was the demonstration purpose. Let's move back to the slides again. And in the slides, as we have already explained the solution summary, and these are the windows which we have already showed. And as we have mentioned that we have already tried with 120 images at the same time, and our application is nowhere calling GPU. It is not calling GPU. That means everything is processing on the CPU. That much efficient the model is. And this is one after one. This is the folium map that screen is. And let's talk about the model. Now, in the modeling, the scalability and the how lightweight the solution is. That's why we did not no, that's why we did not exceed the IMDSZ parameter 2024. And after making lot of iterations, we able to get this this MAP value. But we have make sure that in after every 100 epoch, we started to increase the validation data set. Now, that is the way how we make to how we able to stabilize the model. And here we have observed one thing, that in case of small objects like plastic and that kind of thing, the batch size is when the batch size is getting small, the model is getting more stabilized, and that's why as it can be seen that in our last green marked model, the best side is 4. Now after trying with a lot of model with the TensorFlow's repository, we have set with the yellow V8's nano model. The reason is clear that it is the lightweight solution, and its own interference takes very much less time. All about in our case, it is taking 200 millisecond, which is very much less compared to other techniques. Now, as we have mentioned this in the previous solution, now we will talk about the scalability of the solution and green solution. As we have mentioned that our solution doesn't require the GPU, and it is explicitly not calling the GPU. Now, how this is useful, since it is not requiring the GPU, that means it proves that it requires less computation power. And at the beginning, when we are selecting the model, we make sure that we do not get off from the yellow V8N and IMDSZ 1024 parameter in order to make it runnable in CPU. Now, since we are running it in the local device, that means we have the opportunity to switch on the device whenever it is not in use. That means it will drastically reduce the carbon emission. And one more thing we need to remember, this in case of cloud, in case of the solution, in case if we upload the model or plot the model in cloud, in that case we have to upload the 15 MB drone images in the cloud. That will take much time, and in more areas there may be a internet issue. But in our case, the solution is in our case the model is locally deployed, so we do not need to upload those images. And as it can be seen that even though images are not at all compressed, we wanted to show the worst scenario that is possible. That's why we uploaded the images without compress, and as it can be seen that it is performing very well. But let's talk about more scalability point, that as we have mentioned, less computing power required and ease of implementation. As we have mentioned that we have used a realistic approach, that taking the help of the local people and removing the plastic. And here we have make sure that we do not use those that much technology which increases the cost. So it obviously makes the solution scalable. And the business value of the solution, as we have mentioned, that we will take help of the local people. Now this will help us to generate employment for the local people. Now this is also a business value. Now one more thing, that whenever and we know that many governments are investing lot of money to solve the plastic problem. Now and if we can give them a valuable and cost-effective solution, then that is also a business opportunity or something. But and one more thing we need to remember, that the collected plastics may be used as a raw material for the local plastic industries. And if the concentration is enough and the withdrawing cost is less compared to that, then it is also a business value. And since our solution is free from cloud development, it makes the solution cheaper. So that's why if there is a similar solution who is solving the same problem, then also we will get an edge because of the less cost. Now let's talk about the feasibility and sustainability compared to the cloud deployments. Now as we have mentioned that the cloud deployment will cost a lot of resources, and even if we and we know that the more the distance is from the cloud storage, then the more the green emission will be emission will be more. And in case of, as we have mentioned, the drone images will be about 15 to 16 MB size. So that means uploading them will take huge time. So in that case, for our case, that is not the case. We don't need to upload. That means that's the issue. That's not the issue. And in our case, that in most of the remote area there is not a proper internet connection. So that the solutions that require a heavy internet connection will not be able to compete with this solution where the model is completely doesn't require in cloud deployment. Now, best point of our solution, that in case of our solution, we have used the Qt5 framework. Now, using this Qt5 framework has a one benefit, that Qt5 framework is both available for Python and C++. Now, since it is both available for Python and C++, that means we can rewrite the application in C++ also. But there is no need to rewrite, because we have consolidated our all Python files in a single Python Python file. Now this will create an opportunity to use the PyInstaller. Now when we will be used to the PyInstaller in a single Python file, we will be able to export our application into Windows executable file and portable Windows executable file, which will be much better, which will allow our solution to be useful to the common people who are not tech people. Now, possible integration in our solution that we have also tried to make a mobile app using API, and we want to share a few seconds. So as you can see in the video here, that after logging in, it will be in the feed section, there will images will be shown, and on clicking the images, this will directly open the geotag URL and open the map from where the plastics need to be removed. But we dropped this idea. The reason behind this, that in case of API call, the time it takes in inference is 30,000 milliseconds, which is much longer than our current solution, which is just 200 millisecond inference time. That's why we have only provided this solution, our PyQt5 solution, which we have shared with the REVA University portal. So at the end, we are thankful to the REVA University and Kyndryl for giving us the opportunity to present in online mode, and that was from all our side, and we are open for the questions.
Thank you, Team Sagar, for your dynamic presentation. We are open for Q&A session. I guess there are no questions from our judges. So I'd like to thank Team Sagar for your presentation. Next up, we have Team Infinity. Let's keep this excitement going. Give it up for Team Infinity.
Have the chief guest of the day here, Sankara Srinivasan. Sir, thank you so much for coming. Thank you so much for coming. And please accept a bouquet of flowers from us as a token of our appreciation and gratitude. So Shankara is the vice president of Kyndryl and has been supporting this the initiative from the beginning. Thank you so much. Let's continue. Thank you.
So to play the video, play after the ball. And it's not. It's not happening. Thank you.
Plastic will be the main ingredient of our grandchildren's recipes. Good evening, everyone. Myself Sandra M, and this is my teammate Bimalva. We are Team Infinity, and we are here to embark our journey not just along the banks of the river, but also right at the heart of the global crisis that is affecting us all. So, what exactly is the problem?
So picture this. You are standing by a pristine river. The sun is glistening over the water, and the soothing waves are soothing your soul. So this is a stark problem that our rivers are facing.
There is something that shouldn't be there when you look closely. A floating plastic bottle and tons of other plastic elements. And there are several questions that comes to our mind. Who is going to solve this? Who is going to help those people who want to leave our rivers of such plastic pollution? Well, all these questions are lingering in our mind, not anymore, because ladies and gentlemen, we are here with an end-to-end lightweight application that detects, counts, and locates plastics through images of polluted rivers. So, in order to understand the solution better, we need to understand the core of the problem. How does this whole process of cleaning rivers start? First, the group of organizations or the group of friends or the people or the company who want to clean the rivers have to get the government approval or have to sign the contracts. And then they start with these processes, that is data collection, decision making, surveying, tracking, visualization, calculations, etc. Most of this work is done manually, which takes a lot of time, cost, and this reduces the amount of efficiency and increases the time. And then it's the implementation. That means they go and find the hotspots, and then they implement the hardware or the start with the collection of the garbage. So our application aims to ease this part. That means help to visualize, analyze through the pictures that can be taken from drones, etc. And those pictures can be analyzed easily.
This is the architecture of our project. It's a very simple project. We have a very simple interface with just two buttons. One is the upload image button, and the next one is an upload folder button. So as the button suggests, for the upload image button, you can upload a single image and it will give you a segmented image as an output. It gives you the count of the plastic in that image, and it gives you the location of where the image was taken from. Similarly, in the open folder button, you can give an entire folder full of images. So it will give us output as a file, as a CSV file with the file names, with the counts of plastic and the location or the geo map location or link of the various images. Yeah. So we build our user interface, very simple user interface with the Tkinter package of Python. And then the model, we actually tried training a lot of models. We tried YOLO, we tried R, CNN, and then our MVP was not that great. So then we went on to use RoboFlow itself to train the model. Actually, a V8, YOLO V8 segmentation model has been trained with RoboFlow.
We also use other powerful Python libraries such as Pillow and Pandas, etc., web browser and PyXif to extract the geotag and other powerful functionalities. So the innovation is the seamless extraction of geotag and the correct organization of data. The output is given in such a way that there will be no cluttering. And then the robust foundation, the whole application is built entirely on Python.
About the scalability of our prototype, as our output is a CSV file, we can use it further for visualization or can be used for any other purposes for any other data science projects or anything else. And the next part is our project is completely built on Python, and we use very commonly used libraries. So we can integrate and upgrade it very easily, and we can use our project as a module for any other projects. That's it.
So now we would like to show you a small demo of how the application works. So you can open the application. Use the rows to API. So there are two buttons. One is upload the page. You have to simply visit the time for this. Check. And then repeat using our plastic and also your application. locations and also the count. Now we can also run the prediction for a folder which contains a large amount of images. Usually, when you will be collecting images, it will be in a folder and there will be a large number of images in a single folder. So to run it, first, you can click on the upload folder button. Once the folder has been uploaded, it will give you a CSV file that shows the names of the images, the count of the plastics, and also the geotag location for each image. You can create this. And when you are saving it, it will be saved in decluttered format. That means CSV file will be saved separately. We can also save a folder which contains all the predicted images in order to compare the different images. As you can see, there will be a CSV file and also the all the predicted images. Presentation.
The business value tags to any business or NGO that uses our sorry, that uses our project is it gives us the accurate count and location of plastics available, plastics in the rivers. So it can the company or NGO can deploy resources and it can use its time and cost efficiently.
So our target audience is basically anyone who wants to clean rivers, and to help with that process, all the people that have been shown here are our target audience. So we would like to go on with the final remarks.
Yeah, so as a future scope of our project, we are planning to we can directly implement it on drones which are collecting the images, like so that's one of the future scopes. The next would be to actually show some visualizations and add some data value to the CSV file that we are creating.
We also would like to mention the challenges that we came through while developing this. So a few of them is that in order to go on with the college activities and also this project, we experienced that. And the next one was the distance. We don't live at the same place, so the communication was a bit of a challenge. And the third one, the most important one actually, we tried training different models. We started with faster RCMN model for object detection, but then we realized that it's better to go just for segmentation because that's the main task that we would be requiring. So we tried masked RCMN for the next, but we did not receive the very good MAPs. It was around 32. So we then jumped to Euro V8, and we were about to get around 50 MAP. So after that, we realized that it's better to use to train our model using the RoboFlow website itself. So we trained it over there itself, and then using the API, we integrated it in our application, and we used the free credits used by given by RoboFlow to train our model. So that was all about our application. We would like to conclude by saying that sometimes hard, complex, and big problems requires small, easy, and lightweight solutions. Thank you.
Thank you, Team Infinity, for your sensational presentation. We are open for the Q&A session.
Since we are running out of the time, yes, thank you.
So we'll restrict it to what is the usefulness of this. This looks more like an academic exercise using PCL, teacher impact, and we are trying to do that. What the end user will do, why he has to upload files and all those things. AI should reduce, no? Complex problems require simple solutions. Click of a button and should get plastic is there, go there and think that. It contains so many things. Any defense for that?
Actually, we didn't know what to come up with the solution. So we talked to some organizations, like we interacted with.
About mentor, have you discussed with your mentor?
Yeah, we did discuss.
So during the first time when we started with the project, we interacted with a plastic fishers team and we asked them how is the whole process done. So they told us that first they have to go where they have to discuss it and they see the satellite images and then they go to the place. They take picture and they manually also stand and count the number of plastics. On the basis of that, they will decide, okay, this will be the hotspot that will look like that. So we thought, in order, instead of looking at the whole problem as a broad one, we should take one single problem at a time. And that was the part where they took so much time to decide on all those things. We use this application. Also, as a future scope, we are thinking about the mapping and showing more visualizations for this application. Thank you.
Thank you. Thank you, Team Infinity. Next up, we have Team Vision Giants.
Hello everyone. Hello everyone. So we are Vision Giants. I'm Sahil and along with me Baladev. So we are participating in this plastic waiver hackathon for identification of plastic waste. So this is the agenda for us. We'll be covering solution summary, then architecture, then demonstration of the prototype, followed by innovation scalability, then business value and final remarks. So we are working as a data scientist in Nissan Technology and Business Center India. So this year marks 15 years of our company. Coming to the solution summary. So basically, we have tried covering the majority of the aspects, like starting from pre-processing of the images, and then followed by training, and then also tried implementing the MLOps implementation, followed by deploying the solution on cloud. So it starts with the image quality assessment, which is done using different matrices, followed by the data analysis report generation for understanding for getting different insights on image data. Then we tried training our model basically using different models like through YOLO, like YOLO V5, YOLO V7, YOLO V8, out of which we found YOLO V8 was giving the best results. So for this, we took additional some more images from the original dataset. With that,
just to store the actual data in the Google Drive, and then the metadata and configurations of our file zip, GitHub reference, so that anyone can later point of time come and reproduce the data itself. So then we are going for pre-processing part. In pre-processing part, we are actually controlling first image quality by using some kind of scores like crisp score, then light ray score, and all. Then we are going for creating like performing EDA on top of the data what we have. So in where actually we are trying to create one report, which is actually consists of some kind of distribution analysis with respect to the data, so that we can actually measure the briefness of the data, how it's actually varying. Then we are going for training. So it is actually iterative process because the data what we have is a very, I mean, you can say even if 3700 images we have, but actual object is present is very low. So we are iteratively aggregating those data using some kind of techniques, like different techniques, like you can say there are multiple techniques are available in algorithm. So we are using everything just to iteratively training, just to increase our training So once we train our model, we are going for fine tune our model using so once our model is best model, like we are taking two best models, and one big model actually we are trying to go for multi-object tracking with respect to byte track as well as photosat. So after also that, after this. So later, just to solve our model quickly, we just built some Streamlit applications, which is actually consists, I mean, can take input as video as well as image. Then we just try to automate those things. So whatever the model we train, just to experiment tracking and as well as you can say model registry, just to store our artifacts, we are using Workspace's platform, which is completely free. So also we are using these DevOps actions to, I mean, automate that pipeline. Whenever there will be some kind of change in our report, we'll automatically push that things into our standard cloud. So we are also tracking the training processes through this, you can say, other application which is actually hosted on Hadoop space. So finally, also we are creating that output whatever in the format with image geo coordinates. This is it.
I think sound is not coming. Okay. Yeah. Reduce weight from seekers. So next, coming to the innovation. So like as seen in the video, we have performed a lot of things, starting from assessing the image quality. It is performed using the BRISC score, sharpness and brightness calculations. Then the data analysis report, as shown in the video, is used for getting some insights on the data by from the different plots. Then we did the model fine tuning through ensembling technique by using the non-maximal separation and weighted box fusion approach. Then for the explainability, it was performed using IconCam for understanding the significant regions. And coming to the multi-object detection tracking, it was performed using BindTrack and GoShot as seen in the video. And for the MLOps implementation, we did using the GitHub for code repository, then GitHub Action for building the CI/CD pipeline, and also performing the auto triggering operation. Then weights and biceps for the experiments tracking and hardware storage, followed by DVC, which does the data version.
Yeah. So coming to the sustainability factor in our proposed solution, basically, if I go for the model quantization, if you can see in the figure one, it is that model size is now reduced 4 times, and if you consider this validation time, it is almost reduced 6 times. So actually, it is a significant improvement over the previous model what we have. So if I go for this active learning, so basically we added extra 90 images instead of going for that entire data set that is having that 3700 images. Just to improvise our model itself. Then we actually go for ensemble technique instead of training continuously just to overcoming that training, I mean retraining that model itself. Then we are also using this actually the model whatever we are using, it's a transfer learning technique we are using with respect to aggregated data. Then finally, actually we are trying to give like feature level, you can say visualization for our model, whatever we are trying to create, so that anyone can consider like it's a part of actually responsibility we are trying to come up with. So coming to the scalability factor, so actually we are performing whatever the things, it's open source. If you further wanted to, scale those particular, you can say solution, you can actually go for some serverless engine of architecture, which can actually help you to, you can say, reduce your maintenance cost, and then you can go for your hassle for free development. Then you can go for, you can say, you motivate your application to be event driven and cost effective as well. Then you can also use some load balancer just to, multiple requests are coming from different sources. Then you can actually split it into evenly into different servers so that it can be no going to load in a single particular server. Then you can go for some streaming pipeline pre-processing steps, example like IDC and all, so that it can be efficient as well as the storage clarity also can be improved with respect to some pocket clarity. Then you can also go for some kind of instant segmentation instead of only object detection, so that it can be localization instead it can be wiped out completely.
Into business value, so we have tried covering majority of the things, starting from the pre-processing, which is using the data analysis report, followed by the model training. So we improvised the model and we got good map score, followed by the multi-object tracking using various techniques. Then explainable AI was also performed, followed by deploying the application on the cloud, and then a model configuration was done to reduce the inference time as well as the model size also, which was a significant improvement. And then MLOps was performed to build the pipeline and then performing the auto training operation, also storing your artifacts and for experiment tracking also. So overall, the final remarks is thanks to the REVA and Kyndryl for organizing this hackathon, which helps us to achieve the sustainability and conserving the ecosystem, and also it helps us to gain some insights on object detection of small objects.
Thank you, Team Vision Giants. We are open for Q&A. Humble request to restrict the number to one. Yes.
Did you guys think about calculating the carbon footprint of the waste that are being identified? It's seeing the multi different types of waste that are there, plastic waste. From there, is there any metrics that you folks think about to calculate the report?
So actually, it can be possible because if you see this AWS, that particular scale function, it's already there for kind of calculating like whatever the resources are used. But basically, if you are going for like completely, you can say scratch, if you want to build some kind of thing, it will actually take some other time. That metrics actually, if you see in market, it is there not there something like you can preview. But there is one score that is CO2 efficiency there that is actually calculating from AWS side. So few people are trying to give in their dashboard whenever we go for the pricing base.
That is something utilization of the cloud research. I'm talking about the waste that you are identifying using the images.
So we have tried trying to extract or showcase that how much we are trying to save using the model quantization in terms of the model savings, like we are reducing the model size as well as the inference evaluation time. So in that aspect, we are trying to do, but with that we can go for the calculation for the savings.
I'm not talking about the technical savings or any of those things. I'm just talking about the waste that you are getting from plastic, right? The plastic waste.
Yes.
Can you please think of any metrics that we can use to measure the amount of waste that is there in which pollution is causing? What is the carbon calculations related to the waste itself?
Yes. So whatever the data report generation that we had shown, so it shows the density of all the waste, all the plots that what are lying over there in all the images. So through that we can gain insights that where exactly what are the portions where we have the plastic waste and all. So from that we can get insights.
Okay.
Thank you, Team Vision Giants. Next up, we have Team Weather Eye. Let's give it up for Team Weather Eye.
Let's see.
Oh, I think it's to you.
The first speech. And the organizers, seeing the panelists and judges. We present a team from the office of CTO at Kyndryl. I know my colleagues Abhishek, Jurasya, Rekha. Could have been a better platform to engage each one of you for a theme that is so important for each one of us today. We do have a very short presentation towards the particular thing that we're discussing today. Abhishek comes with a distinguished career of software architecture, infrastructure architecture, software development. Lekha, my colleague, is a data scientist with good amount of experience from software development as well. So we hope that you all will have an engaging discussion, and I look forward. Thank you. Thank you, Subhav. Thanks a lot. So, thank you and welcome to the team. So we have this agenda. I think Subhav has already covered change files. So can you go to the next slide, please? Okay. So we started this hackathon by having some kind of motivation. But now we feel as a barrier. It's like, we are going to solve some very novel problem, novel cause, basically, right? So it's like, we are trying to curtail the plastic waste, right, on a river bed or some kind of, water bodies, right? So definitely, it's a very human tendency, like, we want to self-cleanse ourselves, or maybe, we want to, we want to do a lot of things with our own. But definitely, once we try to adopt the technology, definitely we try to go away. Right? So with this particular hackathon, what we want to achieve here, like using technology, we definitely want to do something which can be leveraged by the government body or maybe the environmental, the environmental system. So. Okay, so yeah, definitely this is a hackathon, and this is what the collaboration with the institution and the company, right? So we definitely want to put a simplified architecture design and the implementation. So what we thought, like, maybe, whatever the technology we are using on this hackathon. So we really wanted to put those this one as a very simplified steps, right? So as you see, like, during this phase one, phase two, or the final phase, the architecture remain the same, because finally what we did, like, we really wanted to improve ourselves on an incremental basis. So maybe in the phase 10, we tried the LOB5, and the notation tool was the row flow, but definitely we went further and we thought, like, why not try with other thing. So we will try LOB8 and Vinyas, right? But the steps was simple the same, right? And then the integration, the SN5, and we were getting the camera image or UAV image as an input. And definitely wanted to identify whether it's a plastic or non-plastic. So definitely, what you thought, like, plastic as an objectional entity, and the non-plastic areas of weights as a non-objectional entity. So, as I said, definitely, this whole journey was all about technical criteria, where we were trying to measure, mean average precision or mean absolute error, right? So definitely what we thought is it's like incremental basis. We adopted the technology. We thought like why not to work with the basic like map value or ME value. So we improved very good in this particular phase of the hackathon where we have achieved map plastic value at a 69.8% for Davis, which is our open innovation challenge for us. Definitely we identified 52.57 MAB value for the Davis. Overall, it was 61.12%, right? So same way, like insurance split, we were getting 14% overall improvement over compared to previous levels. So yeah, we have a demo link where we'll try to define how we integrated Raspberry Pi as our processing model for the object description using development. Yeah. So as I said, we really wanted to put a very simplified architecture here, right? So it's like it's very simple. It's like definitely whatever is coming from the code base, right? It's like once we started the Olo UI, then definitely there were a lot of pre-trained model like Coco and right. And then finally, we also had a kind of you can say we started from the stage also, right? So all these things were there, and finally we had a comparison, we had a comparative study around that, and it's like we try to find the compare performance of this model, and then we try to fine tune with other methods, right? Like there are a lot of other things like we did data accommodation, or maybe we provide some kind of image processing and kind of thing, right? Using a lot of other methods. So we thought to just put a very simplified system flow around that. Okay, innovation. When we so innovation, definitely what we thought, we are implementing our precision value cases by cases, right? So we thought if we achieve something around 65 to 69% for plastic at least, right? So definitely we can target this autonomous underwater vehicle kind of use case, right? Because finally the line between that kind of precision, 69% to overall, right? Then finally, there was an open innovation challenge for identifying non-plastic, which is debris of goods. We achieved that one into this final case. And there was a lot of optimization part was there. So it's like Raspberry Pi. So we are trying to process all this data locally. So we really don't want to, we want to get some kind of, you can say, scaling parameter from the cloud or from the other aspect of the, processing, right? But definitely we want to process the data on global, right? So that kind of achievement we have done so far, and finally we can deploy this model to anywhere, right? Any cloud or any other thing. So real-time monitoring, definitely what we compare as a plastic or non-plastic, there is very much, you can say, there is very much realistic, and by naked eye, right? If I just try to find out something plastic or non-plastic, that is very much matching to the experiment. That's what you can say. Yeah, scalability part, what we are thinking like maybe suppose we have identified our business needs with the AI insights, right? What we are doing. So definitely we have gone through some of identification of pipelining here. Then we thought that definitely we need a responsible AI kind of concept here, because finally we want to manage this ML ops. So definitely we need some kind of pipelining here, the use of technology, which is here, right? So what you see here is the combination of auto ML ops. A lot of things are there, the function of we have identified data operation, data schema, organization, how work together, they can build up pipeline. So particularly this things is applicable implementation which we have done so far. Yeah. So maybe I will over to Lekha for prototype demonstration.
Thank you, Abhishek. With that said, I would not like to do more of the talking, and we have very less time. So I would like to directly jump into the prototype that we have developed using the Euro VA this time. And I have a comparative study done. Can you please skipping the business solution has been very exciting. So I'll directly jump to the prototype where we have used our Raspberry Pi 4B, and we have a Pi camera. We have used a memory card, power bank, and a USB to HDMI cable to have that connection, and the USB-C cable to get it connected to the LCD.
Now, we have the Raspberry Pi installed and we have done the configuration part of it using a few commands on the Raspberry Pi. So I would like to show the equipments that we have actually, we've got the equipments along. So if you are of the LCD, let's take that. So the Raspberry Pi camera looks like this, and it is being connected to a power bank, and it has to be connected to the Wi-Fi so that we have the camera activated, and then detections that can be done. So I have trained the model onto two classes. One is debris and plastics, right? So the debris part it is also being detected along with the plastics. So what we have done is we have annotated our data using the RoboFlow, and the annotated data set has been trained on 8. And we have done a live demonstration. We have collected few plastics and debris, and we have placed it on the ground, and we have tried to see if our prototype detects it well. So if you can see that the two classes that were implemented. And we have the bounding boxes, which are showing the purple. Sorry, in the phase 2, we have just done the one class, single class we have used, which is plastic. And in phase 3, we have used two classes, plastic and debris. You can see it has detected both, right? So we have from the coding part, we have tried to demonstrate how have we, what are the metrics which are related to the precision, and what kind of box loss we have got, and confusion matrix as well, for you all to understand the training part of it. Jumping on to the next thing. So once we have the Raspberry Pi camera installed and the demonstration that was taking place, we had captured the images that were detected onto in this file format, and you can see this file format has the date and the time also showing up along with the plastic count and the debris count. So you can see the density of the plastic as found P1 and the density of the debris as found P2, right? There's a short demo, live demo that is being demonstrated here. If you can play the demo, you will see that so there is a training that is happening in the background on the Raspberry Pi server. Can you just fast forward it a little so that I can show you the real time training and the metrics along with the training. So you can see that as the model, as the camera is detecting the plastic and the debris, it is also giving the metrics here, right? This is a kind of live demo that we have tried. And once this detection, we have got an mean average precision of 69% for plastic, and I think 55%, close to 55% for debris. So we have increased our MAP from 58% last time in the phase 2 of detection of plastic to 69% this time. So we have used, we have done a lot of hyperparameter tuning, data augmentation, and hyperparameter tuning metrics involve the the learning rate that has been considered, and few of the redundant parameters have been actually removed. And then if you see, can you go to the next slide? So there were few improvements in the model that I have just discussed, and I forgot to mention about the epochs. The epochs that were used were close to 90 epochs, and on 90 epochs we got the MAP of 69% for plastic, which is a good score, I believe. And then the fine tuning of the model was done. Like I mentioned about the hyperparameters, right? And final remarks were, to achieve technology savvy, plastic-free rewards. So this hackathon has not just given us a platform to represent our skills, but also have made us learn a lot of things that were very new to us, and the challenges that we have faced with obviously the learning. So the challenges were very much related to the prototype basically. So prototype, we had to install the VNC server in order to just
saved trained models, sorry, detected models, and then that VNC server has to detect its time and the count of the debris along with the density. So that was the hardest part we had. This is all.
Thank you. In weather, right?
Thank you.
We have one question. Can you please come forward, sir? Yes.
Yes.
A good question. Yeah. So I'll answer the first question first. The security considerations that we have taken into account with respect to the data set, is that correct? Okay, Abhishek can answer that.
Yeah, so that was more of basically what we really wanted to keep our model. So once we are ready for the model, definitely we really wanted to put some kind of we really wanted to put this was auto ML or MLOps kind of thing, right? So and definitely people talk about responsible AI, where they really want to use the data very efficiently, right? So there is 50 values, this types of it, right? Definitely we really want to put something there there. Like we are not working the hybrid skillers where we can go something around data coverage and all. But definitely with this kind of model, which we have done so far, local processing, we can have a pipeline where we can enforce this data privacy significantly with the pricing. Yeah. Yeah, so doesn't get to people, sir. There is a question.
Thank you. Yeah. So, yeah, we haven't explored the element of this yet, but that will be our next experiment to do. So we will do with any of the OpenAI or LLMs that we come across with this same model and see what we will see.
This will find device for one time. Model create.
Yes. No, it will be deployed. Yes, we will have to.
Yeah, if you want to the ground and get you some plastic and you're having some black forming around the object. It's like we did the instance model on the edge. So
it has classified OS is being deployed onto the memory card. That memory card is inserted onto the Raspberry Pi. So we have the imager was downloaded on the system. That imager, write the OS to the memory card, and the memory card is being inserted to the Raspberry Pi camera. That Raspberry Pi camera, camera is attached to Raspberry Pi to connect it to the internet and the monitor. Somewhere it will and deploy your model onto that terminal, the Raspberry Pi terminal. You run the model and it detects the plastic and the debris, and also gives it bounding percent on the number of plastics that it has detected, and it is deployed on it. Yes. Thank you. Thank you. Except we have been photograph races here.
Thank you.
सर थोड़ा सा ये रिमूव करिए क्या रिमूव करना चाहिए
You are the limitless universe. Needs no bounds. With potential as vast as the horizon. With abilities as endless as the ocean.
पूरा नहीं किया केवल थोड़ा साइड
Opportunities you experience and learn with time. The power that lives within you, that sparks the light of enthusiasm. REVA University guides students to seek the power within through empowerment. Knowledge is power is more than just words here. It is our motto that we work towards every day. REVA University is known for unlimited opportunities to let yourself flourish through your passions. Conducive environment to propel you forward, to learn how far you can spread your wings to achieve success.
ಸ್ವಲ್ಪ लैपटॉप चाहिए प्रेजेंटेशन ऑक्स केबल में भी रिमूव कर देता क्यों नहीं करना चाहते हैं वो प्रेजेंटेशन है इवेंट नहीं हुआ अभी लाइव नहीं है लाइव पे चांसलर कब तक आएगा फिर लाइव है चांसलर का माइक है हां तो ऑलरेडी माइक है what is it ले भाई सब फुल कर देता है ये आप कैसे हो रहे हैं
10 to 15 minutes before I realized story. But the way things are, I think it's a phenomenal. The first time, I should thank Raju, the person who kept telling me, saying, when I was in Bangalore, from here in Bangalore, I'm based out of Chennai. So, based out of Red Force. So, he got me in and into this, and then when he showed the amount of work that is happening, this is phenomenal. And so I think as I walked in, I said like, wow, this is something a dream come true for. I wish my life had a rollback statement. 35 years back, I can go back and get into a university like this, have a student day, be come and present, do stuff that re-energizes the whole quantum of things. So thank you for having me here. And I think I saw entrepreneurs. Right? I don't see students coming in, companies coming. I see entrepreneurs today coming out and presenting every idea is great. Right? So I think we collectively decide on few people that win, but everybody is a winner. So the amount of participation, the amount of involvement, and this is just not just for plastics. Right? This goes a long way. This is we can use the same technology to prototype beyond plastics. We can go use it in areas where we need intelligence, areas where we need the farm and agriculture space. There's a lot of scope. The prototype is well perfectly defined. We take the best of everything that everybody is defined, start putting it into a prototype that gets into one of the finest products that we can go help the society better. Okay? Thank you.
Thank you. And how to introduce our Honorable Chancellor, right? I think he knows every stone here, every people here, every sentiments here, every emotions here, every skills here. I think he can manage, I think, whole India, I think. No, so managing people, I think, comes very naturally, and building different successful enterprises comes very naturally. No, I think you don't need carrots now, sir. You are beyond carrots and sticks. No, I think we all want you to take rest. You want us to take it forward. So, Dr. P. Shyama Raju, a few words, Chancellor, for everyone who is new here, who has not heard the Chancellor.
Good evening. Last time also through online logged in, I was really thrilled to know about this in the Kyndryl GUI. The way you people are bringing the awareness and take it forward is phenomenal. I don't have words. When Sankara Srinivasan talking about that we cannot stop, at least that when engaging so many people and how few words we can complete. I remembered Dr. S.P. Balasubramanian was talking about Lata Mangeshkar. Till she was singing, she used to practice every day before going for singing. When he questioned her why you are singing from last 60 years, how come still you are practicing? If we practice, we are qualified to do mistakes. That is the reply she gave. In the sense, we can even through mistakes, lot of us will learn. I am learning on daily basis on this, and particularly this project, conducting this hackathon is really useful, and this is the one where it is required. And if everybody contributes like this, and this should be taken forward, I can say every Indian, I can say this. This is very important. First of all, because I have to tell our people, we took a call 6, 7 years back, that is we banned plastic. How many of us really following this? That is important. Let us start from here. If at all anybody is using plastic, and that should percolate to the 16,000 students who are in this campus. A very wonderful program, Dr. Shino, and with Kyndryl and Sankara Srinivasan is here. Everybody is here. I am happy about that, proud about this, and definitely we will take it forward with your research. Thank you.
Thank you. Thank you. I think one thing we know that an entrepreneur like you or everyone else is here, if he can't take risk, whether you're 75 or 95, I don't think you can take risk. And I mean that's in the genes. But thank you so much for being. I think he's the first one to say yes to everything in the university. So that we really appreciate. And I know the results. Now this is the main part of it. We have our judges, and this is for Dr. P. I mean, our Chancellor's information also. We have an amazing set of jury panel, and I would request all of you to, I know time is essence, but I would want you to talk about a few minutes on a little summary on what you felt about the presentations today. And we would start with Usha. I hope you have a mic there. If it is not there, please provide, or you could come quickly here. And then, yeah, I think that would help because you definitely need yeah, please come, Usha. Yes. Usha Rengaraju, who is the chief research, heads up that protocol.
Yeah, the submissions were phenomenal, which because I frequently judge in hackathons, Nam knows about it. So this it was beyond my expectations. Some of you have gone beyond analogs. You have explored how to do experiment tracking and each and every minute things which you have taken. How somebody said how to file an FIR. How I mean you have thought about sustainability. You have thought about how it will actually at the end how it will actually benefit the community as well. So a lot of aspects which you have brought into the table, which is phenomenal. And out of this year in 2023, out of all hackathons I just, this is beyond my expectations.
Thank you. Thank you. I think some fire is coming up there for Usha. And may I request everyone to kind of jump into the stage and talk. Manoj Palniswamy, he's the Director of Data Science again from Kyndryl.
First of all, congratulations to everyone who has participated in this. I know it's been 4 grueling months for all of you to prepare and perfect this pitch. Unfortunately, it's come down to these 4 or 5 people who are here to judge without seeing all of your preparations that has happened in the last 4 months. So I really enjoyed this afternoon, sitting through all of the presentation. And like Mr. Shankar said, I saw a lot of entrepreneurs in the making here. I saw excellent sales pitches, excellent technical demos. Plus, I also enjoyed the evening with the esteemed guests and other jury members. We had good conversations as well. So again, congratulations to everyone, and thanks to REVA University for making this hackathon a grand success. Yeah, it was really a great set of presentations. A lot of work has gone behind each one of them. Hours of work together to do the thing. I almost felt the pitches for their products and asking for investments. That was only part that was missing. Otherwise, I know you are almost there, right? Some of you have even created MVPs, the roadmaps and so on. So you really took it very, very seriously and great set of ideas. And I could see if you put all the different ideas from each of these various projects, 13 of them, this the product that will come out of it will be more complete. That is one area that I was looking at. And secondly, my antennas was all going up, how this technology could be applied to solve many other industry problems, right? As Sankara mentioned, that this is just not only to solve the plastic identification in the rivers, but the technology can be applied in many different areas. And some of you really amazed me. The college students, you are not like all college students. You have done a great deal of work presenting it pretty well. I think as a youngster, probably I was nowhere near to any one of you who were presented today. A really great job.
First of all, congratulations to everyone. And, I still remember when Naveen and I spoke about this, and we were kind of looking at how do we take this further. And that's where, the ideation started, and we came to this idea of hackathon. And from there on, phenomenal work, a lot of work has gone behind, when we look at the presentations, we can easily find out how much hard work has gone behind all the presentations that were shared today. So fantastic, congratulations to all of you. And as many of you said, this could solve a lot of problems. I totally echo that, and I'm looking at more how we could solve a lot of community-related problems with these kind of solutions. How do we kind of take it further to community-related problems? And good sustainability angle in most of the presentations I did. And all the very best again, and thank you once.
In fact, when we speak about events like this, it becomes necessary for us to speak about stakeholders. The first of the stakeholders will be the organizers. The second stakeholders will be the participants. And I've been trained. You should not speak always because we have been told that Priyam Bruyat, Satyam Bruyat, Na Bruyat, Satyam Priyam. But we have been told the other way also. Don't speak like that. Speak PMI. What is positive, what is minus, what is plus, what is minus, and what is interesting. Let me put that from that perspective. With respect to the organization, certainly I'm thrilled in a way that a private company, a private university is coming forward and doing something for this. And this was my expectation from governments and government institutions. They should have called everybody. And IITs, ISC, everybody should have called. Everybody should come and participate. That's what what's been my expectation. The second thing, the plus point is, I have seen personally, I was not involved in certain areas, specifically in guiding or doing anything or things like that. But I was watching closely what is happening, whether it is Dan or Shinu or team. I was watching very closely. It was a tough thing. It was a tough thing. I congratulate both the teams. They have done well. And interestingly, the interesting part is the third one for race. I would like to see that at least 3 or 4 will happen in a year on different things. Now this is for data science or artificial intelligence, one for data science, one cyber security, one for social sciences, which are being completely missed. We talk about all these things, but what was supposed to, that's one thing that we had to. The next part coming from the participants, the plus points or like KK said and others said, the energy. In fact, I have seen more energy from the students, though the other participants were good. I don't deny that. But the students were really good. That puts me into the kind of gear where he says that they have 24 hours of energy, kick them, make them work. They do. You are doing, you did. That's really the plus point. The interesting point is a lot of ideas. In fact, that was one of the reasons we wanted to move beyond the accuracy MAP kind of. So really, I don't think that 91.1 and 91.12 makes any difference statistically. There is no difference. Both of them are winners. That's the reason all of you are winners if you have participated and you did this. The interesting part is you came through and you did end-to-end product presentation, MEP presentation. That is the interesting thing. The minus thing was there was no mention of really how this can be taken to a next level. So that was missing. In fact, I was looking at detecting small particles of plastic is only technical operational. What will I do? What is the critical mass of plastic that is required for me to send my person, send my robot? If you have thought a little bit about it,
That would have been fantastic. But all said and done, minus is only 10%. Still 90% positive because the threshold is 75% for first class. Everybody won. Congratulations. Thank you.
Thank you. It's a pleasure to listen to Dr. Sim always and every other jury members. So I was requesting all of us, let us all stay together and give the gifts is what I was thinking. If you could all stay and let's collectively honor the winners, right? I think that would, I know there would be little inconvenience of standing and making a crowd of the place, but I think it actually our standing ovation to all the presenters, all our presenters who went phenomenally well. Phenomenally well. Okay. So the scores have come, and when we call out the names, request you to. I know this is like my heartbeat is actually high, and I know some of you are, are. So some of us will leave little disappointed today, but I wish that you will take it in the right stride and strive because all of your solutions, all the 15 solutions are there with Kyndryl and REVA. We will definitely reach out to you. So that means maybe a little bit of cash prize you would be missing today, but then keep this as one of the long-term goal that we will make something out of it, right? So please do not go emotional, be balanced. Winning is also part of life. Losing is also part of life. More losing and very few winners, right? So that's how life is. So please be hold on and let the best team be win, right? That is our biggest prayer. I hope the judges have done very unbiased and judgmental scoring, and based on that, this result is announced. These results are final. No further explanations would be given. This is based on the marks that we have received. Okay, thank you. With that, so we have two tracks, as you are aware. We have a set of tracks only for Kyndryl and REVA team to compete. So we had 5 teams put together competing from REVA. Mostly they came from race participants and also the Kyndryl team members. All of them have done phenomenal. We have 2 prizes for them. The second winner under REVA Kyndryl track is, let Chancellor read out the name. Yeah, so they are Keynotes. I would request you to come online because they are coming from Australia. They are. So I'm hoping that they are online. Keynotes, are you online? Cheers,
Yeah.
all of you. Can we have the fire? Wow. Okay. 1 second. I think the glitch on the screen, please. Please, we are not able to see you on the screen. On the screen, Tommy, Sam, you're missing. On the screen, please. Yes. Yeah. So just give us a minute. They are not there.
Yeah, we are here already.
On the screen, please.
Yeah, we are.
This is their moments of glory.
Yeah, we are on video. I think you have to switch the screen.
Sound is not coming.
Yeah, we are on screen now.
It's not connected.
We can see you, and I think we are on.
Sorry. See, the voice. Can you repeat, Jana? Sorry.
Yeah, actually, we are online and on video. So probably you have to switch the screen.
We can see you. We can see you.
Yeah,
we can see
Thank
you. Yes, but your voice is not audible here in this. Yes, the audio is not connected.
Yeah, I think. Can you hear me now?
Go ahead.
Yeah. Thanks you, and it's great to hear that we won this place. And yes, and yeah, it's a great news for us. Thank you. And I obviously have to thank Kyndryl and REVA for making this happen. And with us now is Isaac as well. Yeah, he returned to Yeah,
can
thank
you
you
just
very much.
say hi once more? I think there is some
Hello.
glitch here.
Hello, yes.
This is the problem of online. Sorry.
Yeah.
Okay.
Can you hear us now?
Thank you, Kiernan. We are not able to hear you, but big congratulations.
Thank you.
Thank you.
Okay, thank you. The first in REVA track and Kyndryl track is. Sir, please read out the name. New Talk. Gaurav, Vinay, Raj, please come on stage. I think amazing presentation, unanimous decision by the judges. There were 5 in the last scoring. They came first. Gaurav, Vinay, Raj from New Talk, Kyndryl. Please go ahead. Can go. All right. Thank you. You want to say a word?
Yeah.
Give mic.
First of all, thanks for recognizing our efforts. It's not just our efforts, actually. What we see, in general, what I felt was that there was a thought earlier in my mind whether these solutions are, technically possible or not possible. Today, what we see, and I think KK mentioned it previously, that it can be a final solution. This can be a combination of different solutions put together, and kind of like a Frankenstein from this place, that place, and solve it together. So I believe that a lot of different winners have a lot of good ideas also. Unfortunately, they could not win in the first week. They could not come there. But I can see a lot of the very unique way of it in which they have done it, and it's very appreciative. It's very optimistic, and I hope something does actually become out of this. And yeah, thank you for this opportunity and this exposure. Then we would like to implement this, right? So this is the motivation why we are here. In fact, that is the prime reason why I teach it up, right? These are our main steps. I'm learning many things from them, including your own, right? But the reason why I came for this particular hackathon is to unless we have a real-time project. So I would like to participate from my end. Yeah, thanks a lot. Thank you for everything. Thank you.
Thank you for fabulous work, New Thought, excellent teamwork and excellent solution. Thank you. Now we have the general track, which is the most, most awaited. There are a lot of bigger cash prizes are waiting. The third prize in the general track. Please request Mr. Sankara Srinivasan to announce the name.
Mission James.
Congratulations, Mission James, Sahil, and Debashish. Please come on the stage. Run. Sahil and Debashish Jaina from Vision James. One second, let all of them come forward. Naveen, please.
Yes.
Thank you, Vision James. A few words, maybe.
First of all, thanks to REVA and Kyndryl for organizing this fantastic event. So this has actually set up a benchmark that how we can achieve a sustainable ecosystem. So thank you, team. And also a big thanks to actually I'm from R&D DCL. So big thanks to Bhadev for supporting me throughout this event. And our team management, Lalit and all from R&D DCL. So big thanks to them for supporting and trusting us that we can go and get and win. Thank you.
Thank you. Thank you. Thank you. The second winner, second prize, which is 1 lakh rupees, goes to, request Chancellor to announce the name.
Syntax layer.
Syntax layers. Mohammad Firoz, Feron Rahul. I know they were a little disappointed that they had so many features to show. They didn't get enough time, but you have made it. Second prize of 1 lakh goes to Syntax layers. Mohammad Firoz, Feron Rahul. Congratulations. Want to hear a few words? Young, I don't know, how old are you people? 18, 17? 19. Yes. Please, please, please. We can carry that. Please, please.
Okay, thanks for this wonderful opportunity. Actually, you worked for days and nights to come here.
Yeah, I know. Yeah, exactly.
Thank REVA and Kyndryl for this opportunity. Just thank you.
Yeah. The amount of hours we can imagine by looking at their presentation and the product that they have built. Please keep the spirit alive. Thank you so much. And now may I request both our Honorable Chancellor and Sankara Srinivasan together announce the first prize of Kyndryl REVA sponsored Plastic Free Rivers AI Hackathon Awards goes to EcoGuards, Manav, Pratham, Abhinay, Anurag. 1.5 lakh cash prize. Where is the mic? It's there. It's there. There's a mic. Hand mic. Hand mic. Take the mic. Take the mic is there. You can play it.
Yeah, actually just thankful to everyone in senior here. So we are thankful for this wonderful event.
No, we're not seniors.
Like experience.
We just graduated with a few years of experience.
So even the hackathon experience was very wonderful. We were asking many questions on Discord and like everyone was very helpful throughout the event. Thank you.
Thank you. Thank you. I think
And also thank our mentor also who provided us valuable guidance throughout the phase 3.
Who is your mentor?
Ravi Shukla.
Okay, Ravi Shukla. I think you would have come here, but we would convey the regards. Thank you. Thank you. Thank you. And to join for the photo. No, I think we will just request you to take the seat, and I will give you a. I mean, the final part of this commitment is I have to mention and remember a lot of people who have helped in this hackathon. So Yeah, I'm just thinking where to start because I don't like scripted speech, so I don't have a list. But it comes from my heart because I know from the day one that we started thinking. I think the first person that I know it's not in order, but it is from the memories that I have that I'm going to read out the names. And I think the first person and the last person I should thank is Danana Mitra. Thank you so much. Thank you so much. I think as a project getting it done. I think our team is like a big fan of yours, how project management has to be done. Thank you so much. Thank you so much. And the entire team of Kyndryl, I know the senior members are here, but I know how Naveen and Sankara, because we don't have much conversation, but Naveen has been following up in almost all the meetings. He was part of it, irrespective of his busy schedule. And then we had some wonderful sessions by the Kyndryl expert teams. So I would mention Somo. Somo is here. Yes, I think Somo and Vikram for sharing us. Okay, I think the gas is over there. So okay, so for your wonderful technical sessions and our series of mentors who worked with the individual hackathon mentors. So starting with Ratnakar Pandey, Pradipta Mishra, Ravi Shukla, I could see Archana Dikshit, Arpana here, right? Aparna, sorry. No? Okay. Archana, sorry, I think it's my bad. Archana is not here. Okay. So Archana, Kumar Saurav, excellent. Kumar Saurav and Archana. So thank you so much for being wonderful mentors to the team. And okay, some life it was still okay. So and the entire Kyndryl support system, because there are a lot of people who have helped, starting from Dr. Vishnu, Shandanu Nikam, and Debashish, who has helped us to identify the problem statement, worked with us relentlessly, religiously to develop this whole concepts and come to the fruition today. They have been there all through the steps. And I'm sure I will miss a lot of people, but I remember with a lot of gratitude the corporate communication team from Kyndryl and everyone else who were part of it, Solomon, Ronnie, Arun, and Sheena, and Reena, and Shait, somebody else. Okay, I'm missing the names. Okay, and I should definitely thank KK and Naveen and all of them for being there, and especially for the jury members. The jury members, I think we have been we are able to do unbiased judgment because of your wisdom and the ability to ask the right questions to the right teams. Thank you so much, individual jury members. We are really grateful because it's not a each team and scoring, because a lot of money is involved in this and your decision matters a lot, right? So thank you so much for being such good sport. And I think we should thank REVA management team. Otherwise, we don't have an auditorium like this. We don't have facilities like this. I should thank from Chancellor for setting up beautiful infrastructure, because his vision is that bring everyone to the campus. Usually we race used to do a lot of events outside, but I think we should do more events in the campus. So beautiful infrastructure. I know a little bit of technical glitches. Thanks for bearing with us, but amazing infrastructure. Thanks. Yeah. And we would have to thank the entire second line of leaders which Chancellor has. I think Professor Dhananjaya, I think you have been a silent city. And I must also thank the team. I think Race team. Can you hear for Race team? Okay, so how do I thank? I think I should. A few people definitely comes on top of my mind. Manmohan was leading a lot of things on this project. Jordan was leading. Yeah. Manmohan and team, Nikesh and Amit and Samuel and Jordan and team, IT and the other part of it, technical part of it, Dr. Rashmi, Professor Paramesh, and the entire support system, our business development team, and our academic delivery team. Everyone was part of all the process that which we have been. I think we are all little more AI intelligent now, right? So hope our team has learned. And I know there are a little bit of certificates and jury plaque, etc. Because of the paucity of the time, we would request that we would kind of close the session. And but there are certain things that which we have to hand it over. So participants, please stay back. Jury members, please stay back because we will have to do a little more of closure. But otherwise, it has been a phenomenal experience, great learning for all of us, and I hope we would achieve that plastic free. I'm not sure plastic free status, at least at our own individual lives. Let's reuse, recycle, and reduce. Right. So let's take that pledge and use AI. Whatever that the weights that we have created, let's clean it up. But let us ensure that the next generation